Welcome to Learning Web Development with the Mean Stack. My name is Mike Perino, and I'm a 15-year veteran enterprise application developer. I've architected and implemented applications for small businesses, government agencies, and Fortune 500 companies. I've spent the vast majority of my career working on the .NET framework. However, recently, a little over a year ago, I retooled to JavaScript and specifically the Mean Stack. I tried all the front-end frameworks I could find at the time, including Backbone and Ember, but Angular won by a long shot. Server-side, the idea of using the same language was phenomenal. Then to find that Mongo stored its data as JSON, I've not seen a more fitly joined stack in all of my career. We are going to be building an enterprise database application. It's an ordering application. It's not going to be so complete that you could run with it after it's done, but it's going to be what I believe is the most comprehensive course to date. This application will introduce you to about every concept you'd ever need to know, full stack. You will be introduced to Bootstrap, D3, a neat little table library that I like called Data Tables, Angular Bootstrap, and so much more. In the first section, you'll be introduced to the Mean Stack and its components and the tools that we're going to use. Right out of the gate, we'll actually build a full-stack Hello World application. In the second section, we'll dive right into backend-less development in Angular, adding components to the dashboard, and then onto listing and adding data. In the third section, we're going to finish up the add, edit, and list forms and move right into how Angular Bootstrap Date Picker works. In the fourth section, we'll finish off the dashboard, client-side, without any server-side data yet. The application is almost fully complete. In the fifth section, we'll dive right into the server, looking at Mongoose, Express, and more. We will also hook the API up to the client side and add data full stack. This is really exciting stuff. In the sixth section, we're going to dive deep into automated testing with Karma and Jasmine. We're going to do all that client side. We will use Mocha and Chai server side to achieve the same thing. In the seventh section, we will actually deploy the application to Heroku and see it run live. That's what this is all about. Finally, in the eighth and last section, we will be discussing how you might use Sublime instead of WebStorm for your development. Now, when it comes to prerequisites, there's really only one thing that stands out, and that's JavaScript. There really will be no foundation on JavaScript, the language, and its core abilities. You're going to have to bring that to the table. I look forward to seeing you in the videos, and I look forward to making a difference in your life.
Welcome to the first section of this course. This is the first of an 8-section course on the Mean Stack. Over the next 4 videos, we will be introducing you to the stack, demystifying the acronym, and introducing you to the tools needed to build an application on the Mean Stack. This section is your foundation. This is the first video in this section. What is the Mean Stack? In this video, we will be covering the following topic: understanding each technology involved, also what technologies are server-side and what technologies are client-side. M is going to be for MongoDB. This is the database that's used to make up the Mean Stack. Document databases are a big change for those who have worked with relational databases for a long time. However, they are very well fit for JSON data. This connection will make a lot of sense later. E is for Express.js. This is the routing and middleware framework that's used to make up the Mean Stack. It is powerful, configurable, and unopinionated. It further has a very large community and a significantly large number of plugins to help you do everything from cookie parsing to authentication. A is for AngularJS. This is arguably the most matured and unopinionated client-side JavaScript framework on the market today. It helps you when you'd expect, gets out of your way in kind, and provides you with everything from routing to API interfacing. N is for Node.js. This is the networking and execution engine behind the Mean Stack. It is in fact its own web server, pound for pound, depending on which report you read. It outperforms any web server on the market. It's used in production by companies like Walmart. It is tried and true. Now that we understand what the acronym means, let's be clear on what technologies are used where. MongoDB, Node.js, and Express.js all run and reside server-side. AngularJS is the only client-side technology. The beauty of it all is, though, that there's only one language, JavaScript. In our next video, we are going to be discussing what tools you need to do the job. I look forward to seeing you in that next video.
We are continuing the first of an 8-section course on the mean stack. Over the next few videos, we will be focusing on the tools. First, what tools you need, and second, what they do. There's a lot to cover, so some of it you will learn on the fly. But let's get a good foundation first. In the previous video, we looked at what the mean stack is. In this video, we're going to start discussing the tools. You can't do a job without the right tools. Winston Churchill once said, "We shall neither fail nor falter. We shall not weaken or tire. Give us the tools, and we will finish the job." In this video, we're going to focus on installing and using WebStorm. The foundational tool is WebStorm. You can find it at JetBrains.com. It's professional tooling for JavaScript applications. It supports debugging for Node, run configurations for quick access to customized startup needs, IntelliSense, smart refactoring, Git integration, third-party conflict resolution, snippets, and much more. I want to showcase one of the most basic features that are really going to save you time during coding. Div.row. It's going to add a div, but also add the class row when you hit tab. Great feature. You can also do this with multiple classes. Div.call-md6.columns is going to put 2 classes on that div. So if you were building a grid and you wanted to use 6 of the 12 columns, you can do that really easily without typing out all of the syntax. The other thing you can do is use custom attributes like ngenter. You can even supply its value. So here we're going to say div.row, but in brackets we're going to say ngenter equal hover div. And that's going to give us all of that HTML without actually having to type it. This is really going to save you time. We've now installed WebStorm, and it's now up and running. In our next video, we'll look at installing NPM, Bower, and Grunt.
In the previous video, we looked at WebStorm. This is the 4th video in this section. We're going to look at a few tools, NPM, Bower, and Grunt. In this video, we will be specifically getting an introduction to those tools. We'll also talk about installing Node. So first, let's make sure Node is installed. And we'll just simply navigate to their website, and we'll click that install button to download the right package for our platform, and we'll just walk through the instructions on screen. Little pro tip. When running NPM on Mac, you will need to leverage the sudo command because there's some permissions requirements. Alternatively, you could execute this command. Our next tool is going to be an everyday tool for you. The Node Package Manager, or NPM, is very powerful. It's used at the terminal. Thankfully, WebStorm has a terminal built in, and so we're going to use that. Our first command is just going to be npm install. This command reads the package.json file to determine what dependencies are necessary for your application to run. I want to focus on the dev dependencies and dependencies section of this file. There is a distinct difference. All libraries included in the dependencies are going to be considered necessary for the application to run. The dev dependencies are a list of libraries that are only necessary for developers of the system. Little pro tip. You would likely execute this command in your production environment. So all npm install commands would ignore dev dependencies. This may or may not be familiar to you, but it's showing the names of the packages and their semantic version. Here we see some interesting syntax, and so let us visit each one of them. But first, before we can understand whatever *4.1.8 means, we need to understand the npm versioning scheme. They use the semver scheme, which you can find all the spec online. But it boils down to major, minor, and patch. So the first one we'll address is Browserify, whose version is set to *4.1.8. This means that we're currently on the major version 4, minor version 1, patch version 8. The caret
says that we're okay with receiving patch release updates. In contrast, Grunt, it's going to be set to ~0.4.2. And so this means we're okay with receiving minor release updates. There are a couple of other options you could specify. Star or X. This would mean we're okay with receiving major release updates. You could also use the word latest. This would mean we're okay with receiving the latest version no matter what. Little pro tip. Versioning in an actively developed application can be fairly loose. However, once you reach beta and prod, you don't want dependencies changing. At that point, get rid of most, if not all, semantic versioning and just request specific versions. Now, in development, I prefer to use caret over tilde because I still don't want massive changes to my dependencies. Now that we've installed our dependencies, a new folder will be available in our project structure, the Node_modules folder. This is where the source code for all of these dependencies is installed. As an aside, package managers are nice, but don't let their automation fool you. Just like any other dependency management tool on Earth, issues can arise. There are good conflict resolution options, but it can get complex. Now let's discuss Bower. It's like the NPM for client-side libraries like Angular, and jQuery, and Bootstrap, Lodash, and so on. It has a configuration file as well, named Bower.json, that determines what dependencies are necessary. And as you can see, it's strikingly similar to the package.json file. Since it works just like NPM, let's just simply type Bower install. Now that we've installed our dependencies from Bower, a new folder will be available in our project structure, the vendor folder. This is where the source code for all of these dependencies is installed. This folder and its location can differ from project to project. Here you'll notice that we've defined a specific directory that is relative to the .bower.rc file location. Now let's discuss Grunt. While there is much to discuss about Grunt, first let's understand its purpose. It's a build tool. Before we dig into Grunt, the script itself, let's take a look at the Grunt configuration that we've built. Now here we are configuring information that is going to be very relevant, like relative directory locations and file inclusions. You'll notice some interesting paths like source app **star.js. That is called globbing. Sometimes it's not practical to include every file. In fact, most of the time it's not. Further, if you had to include every file, it wouldn't grow with you as you build more code. You can find the specs for Grunt globbing online. Now let's take a look at the Grunt file itself. At the top, you see a bunch of load statements. This is loading the capabilities of each module used in the Grunt script. Next, you're going to see us include our configuration as user config. This is going to be used later in the Grunt script. Now you're going to see configuration for each of the tasks. I'll be honest with you, this can get a little dizzying, but don't worry. Most of these libraries have great documentation. Below the task configuration, we see a very important line of code, init config. And we see that it's receiving the task config and user config variables. Now, this is a good time to see how that user config file is going to be used. If we look just above this line, we see there's a line that uses some syntax like it's ridiculous to say, right? There are many other similar statements where they're using different variables. Well, if we go to the top of the task configuration, we will see that we build a dist_target property and assign it to a similar expression. The value for dist_target is coming from the task configuration object, while the value for dist_dir in the expression being assigned is coming from the build config file. You'll notice that expression is also referencing another property that exists on the task configuration object, the pkg property. That's coming from the package.json file that was read in. While this is getting very dizzying, you can see how flexible Grunt really is and how specialized our script really can be. Excellent. We have now set up NPM, Bower, and Grunt, gone through a good introduction to each of those tools, and now in our next video, we're going to talk about testing. In the previous video, we discussed 3 different tools, NPM, Bower, and Grunt. Now, this is the 5th video, and it's going to be talking about testing. specifically the suites that we'll use to do so. In this video, we'll be covering Karma, Jasmine, Mocha, and Chai. I know that sounds like a long list, but I promise each of them serves a very specific purpose. When you are done with this video, you will be able to understand why each tool exists and what its job is in general. First, let's discuss Karma. This is a client-side JavaScript test runner. It's capable of running tests in multiple browsers at the same time. However, it's also capable of running tests at the command line in a browser named Phantom.js. This is how we're going to run our tests, because we aren't going to have any protractor tests. We also don't have any code that is browser specific. Karma has a configuration file just like anything else. In this file, I want to focus on just a couple of things. The first one is the framework section. It's set to Jasmine. This means we are going to use Jasmine to run our tests, and you can find their API reference online. In this example, we are going to be using 1.x, and you can determine that by checking the karma.jasmine version in the package.json file. There are newer releases, but this is a very commonly used version in many projects today, and so it's a very good base. This is a good segue into our next technology, Jasmine. Now you are looking at a running and passing Jasmine test. As you can see, it's just JavaScript. Jasmine is a behavior-driven testing framework, and so it uses terms like describe and it to provide context when building and reading the output of tests. When building them, you're describing the behavior of a specific unit and saying it should do something. When reading the output, it should be able to determine what features a unit can reliably perform. It's going to take some getting used to, but it's a very good way of describing your tests. This is a good segue into our next topic, Mocha and Chai. These two put together build a very similar testing framework for your Node.js tests. You are looking at a running and passing Mocha test. Mocha serves two purposes in your toolbox. It's the Node.js test runner and the description engine. When you see describe and it functions, they're coming from Mocha. Now, what's interesting is to get a similar expectation framework to Jasmine, we are using Chai. What I mean by this is the expect crud.sendResponse.to.not.b.undefined is Chai. Now that we know what tools we need, in our next video we are going to go over some practical examples of Grunt, NPM, Bower, Jasmine, Mocha, and Chai, so that you can put something literal with this theory. Now that you have some tools in your toolbox, we're going to use them. We're going to see practical examples of each tool to concrete what these tools do. This is the 6th video in this section. What do all of these tools do? You can't do a job without the right tools, but you also need to know how and when to use them. Remember, Abraham Maslow said, "I suppose it is tempting, if the only tool you have is a hammer, to treat everything as if it were a nail." Now, in this video, we're going to actually build some stuff. We're going to modify our Grunt task, and we'll have to use NPM to add a new task we'll leverage. We're also going to add a new Jasmine and Mocha test. Let's start with Grunt. One of the things I like to do is keep my production code clean of console statements. Not only do they just clutter up a live system, they can be inadvertently dangerous. Thankfully, there is a Grunt task that can do this for us, and we're going to add it. So first, we need to add a console statement. Let's just go to the app file and add this line of code. If we were to run the application, every module registered would be clearly stated in the console. Now let's make sure those aren't in our production code. First, let's add the task to our project by going to the terminal and issuing this command. Now that we have the task available, we need to open the Grunt file and add a little code. At the top, we are going to load the task with this line of code. Next, we need to configure this task to modify our concatenated and uglified JavaScript file by adding this configuration block. Now we need to make sure that the task executes during the grunt dist task. We are going to do that by adding it to one of the tasks we've already built. Now, if we execute grunt dist in the terminal and we search the file that was built for the text, module registered, we won't find it. That's because the task we just added removed it. Great job. You just added a grunt task.
Now, let's move on to Jasmine. We're going to spec out the behavior for our register module function in the app file. First, let's create a spec for it by adding a new file, app.spec.js, to the folder. Let's put some code in it. Before moving on, I want to give you my opinion on automated testing. There is a middle ground to be found. TDD is an extreme, just like no automated testing. The greatest value you will ever receive from automated testing is by way of regression testing. This means I've identified a bug in beta or prod, I've written a test to fail it, and then I modify the code to pass it. If the test passes and no others fail, then the odds of collateral damage are smaller. That sentence alone should reveal I'm not advocating zero unit testing. If we go to the terminal and issue grunt k, we find that it works. That ran our karma tests. Now, while that code works, there's something missing. We are not getting output for each test. All we see at the end is some phantom JS version and how many tests were executed. This gives us a good opportunity to modify karma just a little. Let's open a terminal and issue this command. That's going to install a new reporter for us. Now let's modify the karma config file, specifically the template file. We're going to change the reporter's property to use spec instead of progress. Now if we run grunt k, we see some very awesome output. That output is very useful because if I didn't know anything about the system, I'd be able to run the tests and determine from the output alone what features reliably work. Okay, now let's build a new test in Mocha for our CRUD file. Let's open the crud.spec.js file and add a new spec by adding this code. Awesome. Now we have a test that verified we get a 200 when no error or response is sent to the send-response method. We really did a lot. Added a grunt task, a new Jasmine test, we modified karma, added a new Mocha test, some pretty fun stuff. In our next video, we are going to actually build something from the ground up. Well, let me be clear, it's not necessarily the ground up. I've built a template for us to start with that has everything we've built thus far with a few pieces removed that just aren't necessary. But we are really going to build a full stack mean hello world application. Now that you have a strong foundation, it's time to actually build an application. We are going to integrate the entire stack in this next example. We are going to build a table that allows us to change the hello message so that we can build a configurable hello world application. This is the final video in this section. And this is where it starts getting exciting. Congratulations for working through thus far. It's been some pretty deep foundational work, but it's about to pay off. In this video, we are going to build a Mongoose model for a new collection, connect to Mongo, add some server-side code for the GET and POST APIs to select and update the hello world message, and add a client-side view to look at and change this hello message. Note, it is required that you have MongoDB running on your machine before getting started. You can find instructions for installing Mongo on your platform on the MongoDB website. Once MongoDB is installed and running, it does not have to be running as a service, just running. You can get started building your first application. Let's get started by adding our model. This defines what our table looks like in Mongo. Let's add a new file named hello.js under the models folder and add this code. Notice there is no quintessential _ID field defined here. With Mongoose, we don't need to do that. It is assumed. It will be fully managed for us. Let's build out our API. It's going to be fairly straightforward because we're not managing multiple records. We will allow a GET at API hello, and we will also allow a POST that will insert or update depending on whether or not it is already existing. Thankfully, because I've included a nice dynamic CRUD module, this is going to be pretty easy. Let's add a new file named hello.js to the API folder and add this code. Now we need to be able to access our API. There is an api.js file in the server folder that is going to be where we add our new API. All we need to do is require this new API we built. So right after the initial API GET request, which is just a health check, let's just add a new line of code. All right, we have our API built and ready. Next, we need to make sure we can access our database. In our server config file, we just need to set the con string to be MongoDB localhost 27017. Hello, Mr. Grinch. We're getting close, but we still need a UI. Let's add a new folder named hello to the source app folder. This is going to be for our hello module. Now let's add our module file, so let's add hello.js to the new hello folder
let's drop in this code. Now, this code is introducing some new concepts we haven't covered yet. Right now, we just need to trust these are necessary, and we'll go over them later. But let's just break it down like this. The $resource, named hello, is our way of getting back and forth to the API, and the controller is what's going to make our view work, and the directive is how we're going to place the view on the page. Speaking of the view, it's time to build it. Let's add a new file named hello.tpl.html to our new hello folder and drop in this code. Okay, so now that we have some code to run the view, and the view itself, we need to get it onto the page. We are going to add a line of code to the app.tpl file to show this new hello view. So we've completed the code. Let's run it and try it out. Go to the terminal and execute Grunt. That's going to build the application into the build folder and start it up at port 3444 so you can use it. Congrats! You've built your first full stack main application. In summary, you're absolutely awesome. You just built a truly full stack main hello world application. There are some concepts introduced in this video that you haven't seen yet. Mongoose, Express, and all of Angular. Don't worry, we're going to get to those concepts over the next quite a few videos. As you start building stuff, they are all going to start making sense. In this section, we covered what the main stack is, some tools and concepts like NPM, semantic versioning, Grunt, Bower, Karma, and the execution of Grunt tasks. All of those are very foundational. They will be heavily used in the upcoming sections. In our next section, we are going to start building a real-world sales application. This is going to be a practical example of what you might be building for clients or your employer. It's going to include one-to-many relationships, dashboards, tests, and so much more.
Welcome back to Learning Web Development with the Mean Stack. In the last section, we built a fully functional Mean Stack Hello World application. We covered a lot of ground and technologies. Don't worry if they don't yet make sense. They will start coming together. This is the second of an 8-section course on the Mean Stack. Over the next 5 videos, we're going to be introducing you to the application you're going to build, how to build a basic dashboard, and how to add data to the system. We will also introduce you to backend-less development. This is going to actually leverage some of the E2E testing libraries while the application is running. This is the first video in this section, and in this video we will be reviewing the completed application you're going to build and the types of features you'll be leveraging to build it. Now that you have an introduction to the Mean Stack, let's take a look at the application we're going to build. In a sentence, we are going to build an ordering system. Because of time constraints, it's not going to be so complete that you could put it into production, but it's going to cover almost every feature you would use. Let's start with the dashboard. Any business system is going to eventually require dashboard analytics for management at a minimum. Dashboards contain a lot of different types of data, but often show that data in 2 basic ways: graphs and lists. We are going to cover how you would do both. The first thing you see when loading up the application is a graph showing the monthly sales revenue. Along the y-axis, pay close attention to the scale. Some of the months are peaking at the bottom of the x-axis. That doesn't mean $0 in sales. Along the x-axis, we see the month abbreviations as well. Take note to the drop-down below the heading. It allows you to switch between monthly and quarterly sales. Notice the nice animations as the graph updates. That's all coming from D3. The use of D3 in this application will be done outside of the Angular framework. The reason is explicit. Ideologically speaking, you want to wrap everything in Angular and do everything the Angular way. Nevertheless, that's not always possible or realistic. Because of this reality, I have chosen to leave it outside of the framework, so you can see how you might separately implement a third-party library for a specific piece of functionality. You're going to learn how to build this graph. As we continue down the dashboard, we see different types of tabular data: best performing customers, all unfulfilled orders, and all recent orders. These are listings of data that might be very relevant to management. Notice all of them use tables, and those tables have built-in paging and searching. That's because I chose to use a jQuery extension called data tables. Now, the implementation of data tables is actually going to be through an Angular wrapper. This provides you with an example of how you might bring in a third-party jQuery library but use it the Angular way. Concreting the use of this wrapper is important though. The primary reason we can do this easily is because the wrapper already exists. There are times building your own wrappers just doesn't provide any real value.
In this series, you'll get a chance to see both worlds. Now take note. Many people will argue that tables are bad. I'd say that's an ideology, not a reality. Tables are very valid display mechanisms for the right kind of data, and libraries like Bootstrap, which we're using, offer responsive tables. Moving on to all customers, we see a similar set of tabular data as we saw on the dashboard. This is a listing of all customers in the database. Notice, once again, built-in searching and paging for the data table. There are some other features built into this table that we haven't visited yet. Take note that I can change how many items I want to see per page. I can also sort on any of the columns, and the paging is modified automatically when either of those features are used. Moving on to the new customer screen, we see that we can add new customers to the database as needed. These customers have the basic data you might expect from a business entity. Take note to the icon, title, and color of the text here, because under the hood, this is the same form as the Edit Customer screen. However, when we edit a customer, the information changes just a little. Here we see we can add a new sale to the system for a specific customer. The customer drop-down is an example of how you would use the select element. The date picker is actually an Angular Bootstrap component. You'll get a chance to see how that works. Below the header information, you can add a new item, set the description, quantity, and price for that item, or even remove it from the list of items for this sale. Going back to all customers, we need to visit a few more features. Let's start with editing a customer. Notice that each row has an edit and sales link beside it. Clicking that edit link will take us to the Edit Customer screen. Remember I told you to keep in mind the icon, header text, and color when we were on the new customer screen? Well, here you see that we've changed those artifacts, but it's actually the very same template. Here you can make any changes necessary and then save those changes. Pressing cancel will actually take you back to where you were. This is also a feature you're going to get to build because it doesn't come for free. If we click the sales link, we see that a new list shows up under the customer listing all of their sales. Also notice the row we clicked gets highlighted. We are going to learn how to do these two things. Last, but certainly not least, if we click Edit on a sale, we can edit the data for that sale. We could put this sale under a different customer, change the date of the sale, or even add, update, or remove items. Now we saw the application as a whole. In our next video, we are going to be discussing the business requirements for this application. A little hint, they will help identify what kinds of tests should exist. In the last video, we saw the application as a whole. There are a lot of components to this application, and I have purposefully built it for a more real-world enterprise application. This is the second video in this section, and in this video we will be covering backend-less development in Angular. Large and geographically dispersed teams often have one group build the API and another build the UI. However, building the API can get delayed for many reasons. The most common reasons that I've seen are database design and long-running process logic. If the UI is dependent on the API for development, it too will get delayed. This solves that problem. The other problem it solves is data-driven testing harnesses. To test applications with real data, it has to be mocked. In a lot of applications, if this data is already mocked or has APIs for mocking, testing can be accomplished with more ease, both automated and manual. A little pro tip for you. You will find that most regression tests you write exist because the state of the data is not what was expected. Since the data is mocked from the beginning, you will be able to recreate that data scenario, in most cases with an automated test. So this is where it all begins. We are going to build a data model client-side that will mimic our server-side data. To do this, we are going to need some basic CRUD operations like find one, find all, find many, add one, update one, and even delete one. This file is going to use a dependency named chance.js. You don't see it injected because it's a loose JavaScript reference. Now take note, a lot of people will tell you that what I'm about to show you is unacceptable. You always wrap everything in a service or factory and never use plain global JavaScript references. But I find that striking a balance between ideology and practicality work best in practice. Now it's completely up to you, but one thing to keep in mind is if you're not using something like require.js, the chance.js library is already in the global scope, so wrapping it really doesn't do any good. Now, I'm not going to focus on the CRUD operations. They simply operate against an array to provide a seemingly alive backend. I want to focus on the code at the bottom of the file. This code generates the mock data. This is where the fun begins. To understand how this works, we need to understand our data model. It's pretty simple. We have customers, and those customers have sales. Each sale document references the ID of the customer it belongs to. There are two distinct collections, loosely related by customer ID. With that in mind, the loops make more sense. The outer loop ultimately determines just how many customers we are going to receive. Each customer is then built with a method that is structured and ensures consistent creation of customer models. Take note that chance.js is capable of understanding a name, address, city, state, and zip. That's what makes Chance so great. Every customer then has their own loop to build their sales. Notice that each of these loops are using Chance to determine just how many. This means that each customer will conveniently have a different number of orders, for the most part. Then, of course, inside of each sale is a loop for the items. We need a different number of items per sale to make them random. Now that we have generated all of the data, we have a nice data set that should make the dashboard very useful during offline backend-less development. But we're not finished. How are we going to seamlessly build the system with mock data and ensure we don't have to make a bunch of changes when the backend is finished? What about when we actually just want to test with mock data instead of a backend, even if one exists? What if we're testing an issue with adding an entity? Maybe we don't want to mess up the testing database as we narrow down the issue. Well, this is where $HTTP backend comes in. You'll get a chance to see it used there later, but for the backend-less development, we're going to leverage it. Enter the $HTTP backend service provided by Angular for unit testing. You'll get a chance to see it used there later, but for backend-less development, we're going to leverage it. To ensure we don't have to make a bunch of changes when the backend comes online, we need to make sure data access in the controllers is compatible with the real online backend. For this application, we're going to use the $resource service provided by Angular. Well, the $resource service leverages the $HTTP service to hit a RESTful API. This means if we want to use mock data, we just need to intercept that somehow if we can. That's exactly what the HTTP backend service allows us to do. Intercepting is quite easy also. There are different methods that do different things, and you're going to see some different ones used in unit testing. But for the back-endless development, we're going to use the winget and winpost methods. These methods take a regular expression or a static string. I generally use regular expressions because they are more fine-grained and allow me more control to ensure I'm returning the right data for the right call. A good example to start with is the winget for all customers. The API endpoint that we're going to expose for that is API/customer. And so we need to make sure that with a regular expression that we are only picking up that when it's exactly that. Why? Because there's also an API exposed for API/customer/ID. And we want to return different data when there's an ID attached to the URL. That's what the $sign at the end of the regex does. It ensures that's the end of the string. Note that we are then leveraging the respond method to issue what kind of data we want to return. Here we are going to call the findAll method of the server data model we just visited. If we go down the file, we'll see different endpoints that we are capturing. Take, for example, the one that returns a specific customer. Notice that it's looking for an ID, specifically a GUID, to be on the end that is 36 characters in length, has the letters A through Z, numbers 0 through 9, and dashes in it. That's because back in our server data model, when we build a new customer or sale, we give it an ID from Chance's GUID generator. Now take note, the IDs generated by Mongo are not 36 characters in length and do not have dashes in them. This is not an issue because this interception is only occurring when mock data is generated. and not when a real backend is hooked up. We'll explain that later. There is one other distinct benefit to building the data model without a backend. It gives you much more flexibility to build the data model on the fly. This also means that our data model should be complete before even modeling the server, making the server development much faster and more focused on building the right Mongo queries. Finally, this further means that hooking up the server is just a matter of turning off the mock data because our controllers are already hitting real URL endpoints. With these two files in place, and some other assumptions surrounding Grunt that we'll explain later, we are ready for backend-less development in our system. Now take note, while I've already finished both files for this example, they will be living and breathing documents as you build your system. You'll be changing them pretty frequently. The mock backend will change more frequently during development because you're needing to return specific results to mock a real backend. We saw how we might do backend-less development in Angular. In our next video, we are going to be building out a component of the dashboard with some of the fake data we just created. In our last video, we saw how we might do backend-less development in Angular. This is a huge benefit for distributed teams or load testing. Now this is the third video in this section, and in this video we will be adding a list to the dashboard that shows the top 10 best performing customers in order. This is going to require us to build a directive, factory, controller, and leverage a third-party library. We will also be discussing different pieces of the framework that wraps up the application. The framework makes building applications on the main stack much easier because there are some basic functions available to you. While there's nothing esoteric about the task we're about to perform, remember what Paul Rand said. Ideas do not need to be esoteric to be original or exciting. The first thing we're going to do is build a directive to list customers. But we're going to need this elsewhere anyway. You'll notice it's a table, but there are a couple of attributes to take note to. These attributes define how the data tables plugin is to operate. The first one indicates that we are going to build the Angular data table using ng-repeat, and so it will be expecting that. The second is how we send specific options. You might remember that on the dashboard, the customer list doesn't have built-in searching or paging because we only show the top 10 or one page. Contrastly, in all customers, it has those features. The table options is how we'll turn those features on and off. Now, let's declare the directive that will operate behind this HTML. In analyzing this directive, we can see that it uses the customer list template file we just reviewed. We also see this restrict E. That means that it's going to be an element directive only. Now take note, directive names define what they break down to in HTML. They are based off of camel casing. Something like customer list would turn into customer-list for an element directive, or customer-list as an attribute as well. We also see this scope object. This means that our directive has an isolate scope. That means to get data into the directive, we need to send it via attributes. Those attributes are defined with the properties of the scope object. Here we have table options, data source, show sales link, and hide controls. Now take note, attributes use the same naming conventions as directives, except they're always used via attributes. Here table options would become table-options. The template helps us understand how this simple directive definition can turn into a nice list of data. Now back here, we see that the data table's table options are set with that scoped property on the directive. Now it's starting to make sense. We also see that there is an ng-repeat in the table body that leverages the data source scope object. We can also see that we're hiding a column and its header if the hide controls property is true. Inside the controls table data, we see that show sales link property is leveraged to hide and show the sales link that exists on the all customers page, if you remember. Now that we have a working directive to list customers, and it's pretty customizable to be used on the dashboard and all customers, let's get this on the dashboard. Analyzing this file, we see a nice concise template for the best performing customers section on the dashboard. Some of it is just boilerplate markup, but take note to the directive usage on the last line. It's the one we just built. You'll notice that we are sending in values for the data source, table options, and hide controls attribute. Those are going to set those scope variables. Well, that's all there is to this template. It's pretty easy. Now comes the real meat and potatoes, the controller for this directive. To get this directive to actually work, we're going to need a resource and a controller. The resource is going to be used to load the data, and the controller is going to provide that data to the template we just looked at. The resource in this case is pretty simple. Notice it's just an Angular factory that returns a resource, and that resource is pretty simple to define because it's just the URL endpoint for that resource. With that resource available, we need to define the directive for the best performing customers. There are a few new concepts here. The first is that the directive has a controller. That controller is going to inject the newly defined resource, best performing customers, and it's also going to inject something you've not seen before, DT Options Builder. The Options Builder is what's going to allow us to build an object for the table options. This will allow us to turn some things on and off for the data tables table that's built in the customer list directive. The biggest benefit of using a controller on a directive is injection. The link and compile methods are not injectable. In this situation, that was necessary because we needed to recover data and set up the table options in the directive. Take note that this controller is also pretty simple. It executes the query method against the resource we just defined, and it also turns off paging, searching, info, and ordering. This table is simply a listing of customers, already ordered properly, and there are always, at most, 10 of them. Now that we have defined the directive for the dashboard itself, we need to get it on the dashboard. Adding it to the dashboard is as simple as referencing the new best performing customers directive. Wrap that in a little bit of bootstrap magic, and we've got a dashboard. Congratulations. To test it, we just need to execute this command, and then navigate to localhost 3444 in our browser. We saw some more of the dashboard and its component implementations. In our next video, we are going to be building out the template and controller for adding a customer to the system. Now, in our last video, we saw some more of the dashboard and its component implementations. Specifically, we got a chance to use the Data Tables plugin to list data. This is the fourth video in the series, and in this video, we will be building a template to add a customer. This template will also be used to edit later, a resource and a controller. Generally speaking, this is the meat and potatoes of Angular. We're going to start with the template because it's going to be fully encapsulated into a single template. Now, this template is also going to be used for editing a customer, so we will get a chance to review some of those dynamic pieces of the template. The first thing we can see here is an element named detail header. This is a custom directive for the heading. You can indicate to the header whether or not it is an add form and the entity. But let's dig into the directive so we can understand also what's going on behind the scenes. Here we see that the template is simply an h1 tag that leverages the values we injected to change up the display. The isAdd attribute is being used to apply a text color. If isAdd is true, then the class text success will be applied, and thus be green. Otherwise, text info will be applied and thus be blue. Next, we see a similar usage of the isAdd attribute to identify which icon should be used. If isAdd is true, then we'll use the plus sign, otherwise the edit icon. Finally, we get to the text of the h1 tag. We are going to simply concatenate the operation and entity together. But before we finish and get back to the add customer template, let's review the actual directive behind this template. The detail header directive is pretty basic. We are restricting its use to an element. This gives us a very declarative set of markup. This, in my opinion, is the single greatest part of Angular. When reading my HTML, I can read the element names and really know what's going on at a high level. Next, we see it identifies the template we just looked at. And then finally, it does have an isolated scope. While we can't get into all the details here, let's just drop out the fact that isAdd and operation are two-way bindings, and entity is going to be passed as a literal string. Now that we've broken down the detail header, it's time to finish breaking down the rest of the template. The next piece is a very basic form. Let's cover a few things. The customer form.$valid is a way of ensuring that all validation directives are met before allowing a submit to occur. Then the VM save is the actual save operation that we'll review shortly. Next, we have an ng model directive. This is your standard Angular binding for an input, and so that's how we're going to get the user's changes for free. Also notice the ng required directive on that name input. This is going to ensure that we get a name of some sort. Further, because of the aforementioned statement, leveraging $valid, the form isn't going to submit until that's fulfilled. Moving on, we see something new, an ng-messages directive. It also has a condition with an ng-if directive. Remember, ng-if differs from ng-show in that if the expression evaluates to false, the entire DOM element will not be included in the DOM. ng-show just hides it. You'll notice that those two directives are using some esoteric properties. See, when a form has a name attribute, it gets added to the scope as a property. That's why we can reference it by name in the ng-submit. Well, when input elements have a name attribute, they get added to that form property as a property. Each of those inputs have a couple properties of importance. The first is the $error object. The ng-required attribute adds a property to that object named required, and that will be true or false depending on whether or not it's in error. In the case of the name control, we also added the ng-maxLength attribute to identify the maximum length of the string. It adds a property to the $error object named maxLength, just like required. So the ng-messages directive is going to leverage that object, and that's why we set it there. Next, we will discuss the $dirty property. That property identifies whether or not the input has been modified. On an add form, that would only occur if they entered some data and then removed it. The reason this is important on an add form is because we don't want an error showing right away when we open the form. Next, we need to review the div elements inside. You'll notice the ng-message attribute without the s on the end. Notice it's referencing required and maxLength. It's referencing the properties off of that $error object. If those properties are true, then the message in the div will be shown. Alright, so let's put it all together. We are asking the ng-messages directive to use the $error object off of the name form input and display a different message for each validation directive. Further, if the control isn't dirty, we don't want to show the errors regardless of their state. The rest of the form is a bit more of the same, just for different fields. We meet a new directive when we get to the submit button in ng-disabled. Here we are indicating that we want the button disabled if the customer form is not yet valid. We have also added a cancel button that will leverage our $history service to go back to wherever we came from. Alright, so now let's dig into the controller. Here we see a pretty standard controller definition injecting some pretty standard stuff. We are going to hang everything off of the instance of the controller, so we build a property named VM. This is for consistency, so that when we review the template, we see a similar reference in the controller. Let me be clear though, that this local variable has no relation to why I use vm.model.name as the ng model on the template. You'll see why I use VM there shortly. Moving on, we are going to set the isAdd property based on the state name. Here we finally see what operation is. It's either the string new or edit. We are going to initialize the model to a new instance of the customer resource. But if it's not an add, we are going to actually go get the customer by ID and reassign that model. Next, we see the back function leverages the $history service, and we now also get our first look at the save method. Pretty straightforward, really. We take the instance of the resource model and just call $save, regardless of whether it's an add or edit. The reason it's so simple? Because whether or not we insert or update is handled server-side and encapsulated away from the client. When the save is successful, if we're editing, we are going to just go back because we could have come from somewhere else. But if we're inserting, we're going to go to the customer state so they can see the new customer. Reviewing the customer resource above, it's not that exciting. It's a pretty basic RESTful entity with an endpoint. It does define one specialized method named sales that's used to recover the customer's sales. You'll also notice that we're mapping _ID to ID so that the URL is formed properly when we are editing an entity. This is because the Mongo database is going to build an _ID property, not ID. We have one more piece to review, the route. Let's just take a quick look at that. We define a state named add customer. This state has its own URL so that it can be linked to. There's that template we started with. This state has its own URL so that it can be linked to, and there's that template we started with. That's how the system knows what template to render when hitting a URL or navigating to a state. Also, we see a controller statement. That's the controller we just reviewed. But notice the as VM on the end. That's why we use vm.model.name in the view. The VM on the view is a reference to the instance of the controller. The VM in the controller is the same because we assigned it to this. By doing this, we build some real consistency between the view and controller for maintenance purposes. Now that we've built all the components we need to add a customer, let's try it out. This is mock data, so after adding the customer, it will be lost on the next refresh. That's all part of that backend-less development we started with. Now, in our next video, we are going to be listing customers. In our last video, we saw how we might add a customer to the database. We also visited the reuse of something like a page header. This is the 5th video, and in this video, we will be covering building a template for listing customers, a controller for loading the data, and a route similar to the one we just reviewed. We're going to get started by digging right into the template we need for listing customers. At first glance, it's a real straightforward template. It's just a heading and leverages 2 element directives. The first we actually built earlier, so we get a piggyback on that development. The second is one we are going to review later. It's going to actually leverage the UI view named Sales. Focusing on the differences now between what we want here and what we wanted on the dashboard. We only wanted 10 customers on the dashboard, and so that means we configured the directive differently. We hid the controls with the hide controls attribute because we didn't need them. We also configured the table options to hide paging, searching, info, and ordering. We just wanted a raw, simple list. Here we're going to have some different table options. We'll see those shortly, but we're also going to indicate that we want to see the sales link. This is something that's not always visible every time the directive is used. Now looking at the customer list controller, we can see it's pretty simple. We're going to recover the data from the resource by executing query. That's going to get all customers from the database. Also, we're going to configure the table options for paging as full numbers and indicate that there should be 10 per page. That's all there is to this controller. Looking at the customer state, the one we'll use to list all customers, it's just a standard state change. Alright, now that we have a state, a controller, and a template, and we're leveraging an already existing resource, we should be able to list customers. Notice that clicking on the sales link will show the customer sales. This is something, as I stated earlier, that we're going to cover in a video in the next section. Just a little hint, this is a standalone state that leverages a named view. It's some pretty cool stuff, really. In this section, we covered a lot of ground. First, we started with backend-less development in Angular. Then we dove right into building a component for the dashboard. After that, we moved right into adding a customer to the database, and then finally onto listing all customers instead of just the top 10 like on the dashboard. The next section is going to really start exploring more of the feature set by getting it built out. We're even going to get into some third-party UI components. So welcome back to a new section in the course. In the last section, we covered a lot of ground. First, we started with backend-less development. Then we dove right into building a component for the dashboard. And that listed the top 10 best performing customers. Getting our feet wet, we moved right into adding a customer to the database and then finally onto listing all customers instead of just the top 10. Now this is the third of an 8 section in the course. And over the next 5 videos, we will be really exploring the rest of the features of any enterprise database application. We will edit customers and sales, add sales to specific customers, view those sales by customer, and even talk about custom controls by leveraging the Angular UI Bootstrap. This is the first video in this section. In this video, we will be reusing the same view and controller we used for adding the customer. The only new artifact will be a new route. We will discuss how this works and what building blocks had to exist for it to be possible. Finally, we will add a customer to the system. Let's start by reviewing the first line. Taking note to the isAdd attribute, we see our first example of building reusable components. We're letting the detail header know we are in an add or edit operation. If we look now at the controller, and specifically at this line, we can see how we set that Boolean value. If the route name is add customer, then we know we are adding, otherwise we are editing. Moving on to take a look at the operation. If we look at the next line, we see that it's really set based on the isAdd Boolean value. Pretty simple, but we are building something that can be shared between add and edit. Generally speaking, though not always, less code equals less bugs. Moving on now, we need to take a look at the next little piece of logic. This is about as straightforward as the rest. By default, we are initializing the controller in an add state. We know this because of the first line. However, if we find that it's in an edit state, we will then reset the model to the result of a query. Moving on to the last piece of interesting logic, the persistence of the operation. Now here we see that the only difference between an add and an edit is where we go after a successful save. On the add form, we go straight to the customer state, or all customers page, and in the edit state, we actually just go back, because the edit form could be initiated from more than one place. Alright, so with that in place, we do need a couple more things. We need a new state, and having a look at this state, we see it's very basic. It has an identifiable name, URL, template, and of course shares the same controller as the add state. It does have one difference. Notice that :ID at the end of the URL. That means we require some string value at the end of the URL, and we want it called ID in the state params. And we also need to link to that state from somewhere. Thankfully, the all customers view already has that link. If we go back and look at the reusable customer listing, we see that if the controls are not hidden, we have a link to edit customer here. It does have a funky syntax though. Let's go over that. It's leveraging the UISRef directive to build a link. That's good. However, you might remember that the edit customer state required an ID. Remember that :ID at the end of the URL? That's what we're doing when we call it like a function and then send in the ID as a property on an object. Okay, with these things in place, let's see it in action. We learned how to edit a customer. In our next video, we are going to be discussing how to add a sale to an existing customer. In the last video, we learned how to edit a customer. We also got a chance to see how we might add just a few branches to a view and controller so that we can reuse the same code for both adding and editing an entity. This is the second video in this section, and in this video we will be covering the basic building blocks for adding entities to a database: a view, controller, and route. It's going to mimic adding a customer quite a bit, but the view for editing a sale is a bit more complex. We will cover some of those complexities in this video, and then some more later on in another video. So let's get started in the view. The first thing we notice is that the page header directive is reused here. The only difference is in this definition, the entity attribute. It's sale instead of customer. Starting out, we see a lot of similarities to the customer detail form, standard HTML form mixed with some of the attributes you'd expect in an Angular form. Moving on, this is our first chance to look at the select element. The key to the select element is the ngOptions directive. The syntax is actually pretty weird in a lot of cases, but it's pretty straightforward if we just want to list every customer in the list it's bound to. Breaking down the expression, we see that c._id is going to be the value for each option, c.name is going to be the display for each option, c is the alias for each object in the collection, and vm.customers is the collection. It's a little like a for each if you've ever seen one of those. Moving on, we see the sale date. And this is a fairly complex control, but we're going to review it in a later video. So for now, let's just move on. And next, we get a chance to look at a checkbox. It's about as simple as you'd expect. So now moving on, we now see a selection that is used to add and edit the items on the sale. I know a lot of people will argue that this is a bad idea, but when it comes to enterprise database applications, tables are great elements for displaying and manipulate tabular data. Here I've used the table header to embed the add button. On click, it's going to call a method named addItem that hangs off the VM. The following three table header elements are standard and used to provide the true headings for the item, quantity, and unit price. Moving on to the table body, we'll see a standard ng repeat to list all of the items on the sale. You'll also notice that I've used the first table data to embed a remove item button. There is some interesting syntax being used here that we need to review. In the ng click for the button, you'll see the use of $index, and it's being injected into the remove item method. The $index property is always available in an ng repeat, and absolutely necessary when managing an array of items, which we are here. We're going to use the $index to know which item to remove from the array. Moving on, looking at the inputs, we see similar syntax to name the elements. Take note that for binding, we do not need to use the index because we are not going to bind to an array of values, but rather an array of objects. Binding to an array of values can be a little trickier, but can be done. An example might be a tags directive for tagging an item. Moving on, we can see a custom table footer. I'm using this to provide a total of all items on the sale. Taking a closer look, we'll get our first look at filters too. You see that piped syntax? That's how filters are applied in Angular data binding. The first one, total sale, is a custom filter, and the latter is built into Angular. For a second, let's break out of the view and look at the custom filter. Reviewing the filter, we see that it looks a lot like all other Angular definitions. It has a name and a function. Breaking down this function, we are expecting to receive a sale object so that we can leverage low-dash's sum method. Breaking down the sum method, it's pretty simple too, much like the array map method. For each item in the array, it's going to inject it into the function that's passed as the second argument. It's expecting us to return a numeric value that it can sum. Here we will return the answer to quantity times price. Alright, on to the controller. Here we get a chance to see that it looks almost exactly like the customer detail controller. That's probably not that surprising. There are a few distinct differences that are specific to a sale. Here we see that we are loading all of the customers in the database and setting them on the customer list. That's for the select element at the top of the page. Now moving on, we get to evaluate the addItem method. I'll be honest, while there are a lot of benefits to Angular, this one really shines for me. Remember we bound an ng repeat inside of a table to the items list. If we want to add a new item, all we need to do is push an object onto the array. That's it. The UI will respond as expected. Now moving on, we get to take a peek at the remove item method, the one that used the $index feature. We can see here that it's using a standard array function named splice to remove a single item based on the index that's injected. Now let's evaluate the save method. It's very similar to the customer detail controller save method. The one difference is where we go if it's an add form. If you remember back to the link that injected an ID for editing a customer, this is how you do the same thing in code. We are indicating we want to navigate to the customer's sales state and send it an ID, the customer's ID. This is a state we're going to review in the next video. Finally, now that we have all the interface artifacts in place, let's just get a route in place so we can navigate to adding a sale. Here we have a very basic state, and with that in place, let's give this thing a shot. We learned how to add a complex data structure like a sale. In our next video, we are going to be listing a customer's sales. In the last video, we learned how to add a complex data structure like a sale. There was a lot of ground covered there because we actually added a one-to-many set of objects as well. This is the third video in this section, and in this video we will be covering child states, another shared directive for listing sales, and leveraging shared templates for child states. Looking through this view, we're going to find that it looks a lot like the view that lists customers. I do want to review one little feature that's on the list. Taking note to the table record, let's have a look at the ng class directive. What I wanted to do was highlight the entire row in green if the order has been fulfilled. Thankfully, with Angular and Bootstrap, this is going to be trivial. This ng class declaration says that if s.isFulfilled is true, then add the success class to the table record. that will kindly highlight the entire row in green. Having a look at the sale list directive, we see one that looks just like the customer list directive. Honestly, it serves the same purpose, in that it's used in both the dashboard and other screens, so there are ways to hide the controls. You'll also notice it leverages the template we just reviewed and is restricted to be an element directive. This is going to be where most of the magic happens. Here we see that we have a different kind of state name. The dot indicates that it's a child state of the customer state. Looking at the customer state, we need to use the URL property of both to determine what the actual URL is going to look like. Combining those URLs, we would get something like customer/customer ID/sales. But it also has a different way of defining the template URL and controller. Notice it has a views property, which then it has a property named sales. This means that the state, when navigated to, is going to be looking for a named view inside of the current view. You might call it a subview. Take note that it does have its own controller also. Here we see that it's a pretty simple controller. It's going to leverage the params object to load two different objects, the customer itself and the sales for that customer. Reviewing the customer resource, we can see why this works. The get method is going to hit the base get endpoint, which requires an ID, the customer ID. Further, we see that the sales method hits a different get endpoint, API, customer ID, sales, to recover all the sales for a specific customer. Notice it too requires an ID, the customer ID. By recovering those two items and setting some table options, the view is ready for display. This means that when we navigate to this state, it's going to go to the database and refresh this information. So now we need a way to get to this state. Let's start in the reusable customer listing. There is a link that navigates to that state. It works a lot like the other links that require an ID. With this in place, we do need to make sure that the named view exists for this to actually work. If we just navigate to the state, but the view we're on doesn't have the named view, it won't show up. Now take note, navigating to a subview will by definition navigate to parent views on its way. Therefore, navigating to a deep URL for this view will automatically change to the customer's view. Looking at the original list template we built quite a while back for showing all customers, we can see that we have a named UI view that fulfills that requirement. Okay, now that we've fulfilled all the requirements, we need to try this thing out. We learned how we might build a child state to list one-to-many objects. In our next video, we are going to be talking about how we might edit a sale. Now, in our last video, we learned how we might build a child state to list one-to-many objects. It's honestly a bit convoluted as far as the route configuration goes, but it's definitely something you'll need to use down the road. Most of the time, the route configuration is much more straightforward, and like the rest of the ones we've configured. This is the fourth video in this section, and in this video we will be covering the building blocks necessary for editing a sale. It's going to mimic editing a customer quite a bit. It's going to reuse the view that we built for adding a sale, reuse the controller, and have its own basic route to navigate to. Now here's the cool thing. There's not much that differs as far as reusability between this view and the customer view. Notice the same shared page header directive statements. Because that's about the only piece that's important for reuse, let's take a look at the controller. Just like the customer detail controller, we have similar branches around the model and save. We've already reviewed those branches, so let's move on to the route itself. With the route in place, let's review a familiar link to the route. Here you see we build a link to editing a sale. Now that we have all the building blocks in place, and I hope they're starting to look familiar, let's try this stuff out. Now, we walked through the steps where we're using some previously built code for editing a sale. In our next video, we are going to be taking a peek at the Angular Bootstrap date picker in a lot more detail. Now, in the last video, we walked through the steps where we're using some previously built code for editing a sale. As you discovered, it worked a lot like editing a customer. I think you're starting to see some of the benefits of Angular and how it can really dry up your client-side applications. Now this is the 5th video in the section, and in this video we will be covering how Angular Bootstrap can really help with more complex controls like date pickers, accordions, and more. We'll also review one common way of implementing the date picker control. Now let's start by examining what Angular Bootstrap even is. In short, it's a bunch of custom complex UI controls built with the Twitter Bootstrap CSS. The big win here is that we're using Bootstrap, and so they're going to lay in beautifully. Further examination shows they have a lot of different controls that will really fit into your web application, like accordions, alert, button extensions, and much more. Right now, we're going to focus on the date picker. Having a look at how we might use the date picker, let's look at how it's implemented for the add and edit sale. Wrapped in a standard form group, we see that there is a typical label and then a collection of controls wrapped in an input group. The input group is a class provided by Bootstrap, and so is the form group, so they're just leveraging that. As we look closer, we see an input that's labeled as a form control. Pretty standard, and then an input group button, also provided by Bootstrap. This is going to allow us to inline a button. Notice that it's just your basic Bootstrap button inside that span. Alright, now that we've broken down the markup, let's break down the directive. There are multiple directives in use here. Date picker pop-up, is open, close text, ng focus, and then ng click on the button are the ones I want to focus on. The date picker pop-up defines how the date is displayed in the input and classifies it as a date picker. The isOpen directive defines whether or not the pop-up should display. The close text defines what the close button says on the pop-up. And ng focus is a way of popping up the calendar as soon as the user enters the text box. On the button, when they click, we're performing the same operation as the ng focus above. We want the pop-up to display. Taking a closer look at the open function on the VM, we get to see its simplicity. Up above, we bound isOpen to the opened property on the VM. Here, to show the calendar, all we do is set that to true. That's it. We now have a date picker. Here you see a couple of statements that you're going to find common when overriding the behavior of mouse events, specifically click events. Because we have specific logic to perform, we don't want anybody else getting this click event. To do that, we call prevent default and stop propagation. Prevent default is defined as something that cancels the event if it is cancelable, without stopping further propagation of the event. This means any default behavior from the browser will not occur. However, as stated, it doesn't stop propagation. That's why we call the stop propagation. It prevents further propagation of the current event. Basically, it prevents bubbling. In this section, we covered a lot of ground surrounding CRUD operations, template and controller reuse, child routes, and even complex controls via Angular Bootstrap. I really look forward to seeing you in the next section. Now, in our next section, we're going to start building out the rest of the dashboard. We're going to be listing some more data, but we'll also be building our first graph using D3. Welcome back to a new section of learning web development with the mean stack. Now, in the previous section, we covered a lot of ground. We surrounded CRUD operations, template and controller reuse, child routes, and even more complex controls via Angular Bootstrap. Now, this is the 4th of an 8-section series, and over the next 4 videos, we will be covering how to build out the rest of the dashboard. A lot of cool things are to come, including an introduction to D3. This is not going to be comprehensive, as that would require an entire course to its own. We will also build a couple more lists of data to show some different types of information surrounding customers and sales. In the first video of this section, we're going to be covering in more detail what it means to seed mock data. We will be diving into the chance library, why it's important in this process, and just why we augment it just a little with some of our own methods. We didn't cover this earlier because we had been building this application from the ground up, and I wanted to cover this later as we got closer to turning on the full stack. Now, without further ado, let's get going. Now, I'm going to be honest, it wasn't that long ago that I found this library, and it may be one of the most useful tools I've ever used. See, constructing mock data for the purposes of testing viability and performance is very difficult. What makes it so difficult? Different data types alone make it painful because of the sheer number of support functions that it requires. However, there are also domain-level types. Take, for example, a person or business name. Technically, they are an abstraction of just generating a string, but it needs to be done with specific domain constraints. It's not a single string, nor a paragraph, but rather a specific constrained string value. There is a lot to take in with chance. You can see that by scrolling through its API down the left-hand side alone. We're going to use just a few of them: integer, name, address, city, state, zip, capitalize, and floating. There is so much to cover, but that's all we can get to. All right, digging in. Let's first start with the loops that build the data because their logic differs from our use of chance. If we consider what we want to do, it will help explain what we're doing. We want to build a database of customers, let's say a maximum of 200, but at least 100. Each of those customers need to have their own sales, and the number of those sales should differ some, if not only to ensure that the generation of mock data is right manually. So let's say we want as many as 30 sales per customer, but no less than 10. Now each of those sales has items that define how much the sale was as far as revenue specifically. Let's say we want each sale to have at least one item, but no more than 5. With this business logic in place, we can understand the algorithm. The outer loop here is going to ensure we get the right range of customers. Notice, to make that range dynamic, we are leveraging the integer method of the chance library. Next, you see an inner loop for each customer for their sales. It too is leveraging the integer method to ensure we get at least 10 sales per customer, but not more than 30. Finally, inside that loop is the one ensuring that the customer's sale gets at least one item, but no more than 5. Now backing out for a minute, we can see our first usage of chance to build data. The first line inside the customer loop builds a real mock customer object. The new customer function is actually ours, and we'll visit it momentarily, but right now let's focus on the chance calls. This is where those domain functions come into play. The name function, for example, generates a 2-part string where each has its first letter capitalized. You can even send in options to identify whether or not the middle name should be generated or just a middle initial, or you can even ask for a prefix or a suffix. Another cool one is address. This is going to generate a real address-like string with the unit number and everything. You can even indicate that you want a suffix appended like avenue. Now moving on, let's dig into the next bit of chance that really makes a difference for this data set at least. Inside the innermost loop, you'll see our usage of floating. This is how we generate a real currency-based price for each item. We can even identify how many decimal places we want. This is a huge benefit here. Now let's break down some of our custom methods that we leverage. The first one I want to look at is new customer. As you can see, this wraps up the build customer and add one methods. The build customer doesn't do much but put the injected data into the right object structure. The add one is where I really want to get. Look at the add one method. We see that it simulates an identifier field and then adds it to the data store, an array in this case. That's why we augment the chance library just a little. It needs to meet the needs of our backend-less development scheme. With all this background on chance, we can now change how much mock data we build depending on what we need to test. We could build as few as 10 customers if we wanted, or as many as 1 million. This really gives you a jump start on making sure your application performs well, regardless of the real data stored behind it. Now that we know how to seed our mock data, in our next video we are going to be discussing how to build a D3 graph for our dashboard. In the previous video, we really dug deep into the automation of building mock data and leveraging the chance library to do so. This is the second video in the section, and in this video we will be covering how D3 works and why it's a good choice for very functional and interactive graphs, how to build a basic line chart with D3, and then finally how we might change that data dynamically. If this is your first look at D3, don't be intimidated by the fact that it's very low level. That's actually the idea. If you don't need graphs with such interaction, or in other words performing actions on click of a data point or something, then there are other libraries. I chose D3 here because it's becoming popular, but it's also intimidating, and so I wanted to break the ice a little. Now, all of our work is going to be inside one directive in this video. I'm not going to dive deep into D3 and all of its concepts, so a lot of what you see here, you're just going to have to take away and build on. You can leverage this code to build line charts in your own projects, though, right away. Now take note, a lot of the community is probably going to say I'm using it wrong here because I didn't wrap it. Now, let me just make something clear. Unless you're using something, again, like require.js, wrapping it doesn't do you a lot of good because D3 was already on the global scope, and D3 already has an API that is provided through that global variable. All right, with that out there, let's get started. The first thing you'll notice is, yes, I'm actually using jQuery. I know, another deviation from the Angular way. This is going to be important though because I'm going to have to reference that element to build this graph. We also have an initialized boolean that we'll use to determine what we should do if we re-enter the code to display the graph. That's going to play a role in the dynamic modification of the axis and data. Now next, we're going to watch the report type variable so we know when the user selects a different report type. We could do this a different way, and normally you don't want to make changes based off a watch, but in this case it was pretty easy and it's not heavy. Now take note, if we take a quick peek at the markup of the dashboard component for this graph, we'll see that the select element uses ngModel, and that's why we can use the watch here. When a change occurs, we are literally going to get new data and re-render the chart. That's it. Alright, now let's get into the nitty-gritty. Because this is so low level, we actually need to set margins, heights, widths, and respond based on them. Here we are indicating that we want a 20 pixel top and right margin, along with a 40 pixel bottom and left. These are here so that the graph isn't so squished together when it's rendered. Now that we've gotten started with the definitions we need, let's actually get started. You read that right. SVG is the name of the variable, and SVG is literally what we're working with. Here we are defining that we want to draw on the pound chart element, and we're adding the SVG element to do so. Note the classed function call. That's going to add the chart class to the SVG element because it's following the append or selection of the SVG element. It's then going to add a G element to the SVG element, a graphics object, so to speak, and apply a bit of a transform to it to apply those margins that we just defined. Hopefully you're starting to see that D3 is a fluent API that leverages the idea of selections to apply changes to the DOM, much like jQuery. Yep, we're back at the DOM level to do these graphs. Why? Well, for the most part because drawing lines, circles, and squares on a screen is actually a pretty low-level operation by definition. Now stick with me and it'll all make sense. Now to that G element, we're going to apply a path so we can start drawing on the screen. We'll call that our path. At this point, we're going to leverage the reusable method named updateChart and just initialize it with monthly data. By now you've probably realized that the updateChart method doesn't care if it receives monthly or quarterly data. It will handle it internally. Now, before we can understand what the first couple of statements are doing, we have to take a look at what kind of data we expect to receive. Looking at the dashboard monthly sales response, we can derive what kind of data we might be expecting. First, it groups sales by month. So right now, we'd be looking at an object something like this. Next, we see that we are going to map each of those groups, or in other words, we're going to literally transform what value exists for the properties 1, 2, 3, and so on. Evaluating that statement inside the map, we see it's issuing a sum on an array of numeric values. But right now, we don't have an array of numeric values. How do we get to that? Well, honestly, what we want to do is sum up all the items for all sales. That's why we have two sums here. The first grouping gave us all sales for each month. We are now going to map or transform those into a single numeric value. To do that, we have to first sum all items on all sales so that we have a numeric value for every sale. Then we have to sum all of those values to get a total for the month. That's what those nested sums are doing. The innermost sum is summing up the value for every order, and then the outermost sum is adding up all of the orders and making that the new value for each property we mapped. Now we have an object that looks like this. Alright, now that we know what the data should look like, let's evaluate those next two commands. The first one is going to find all of the own keys that don't start with a $sign to weed out the Angular properties added to the resource object. This is going to allow us to map each of those keys to a numeric value. Later on, this will allow us to build an extent for D3, telling it just how big the range of data is. Furthermore, it will allow us to leverage that array to pick off the actual sales values into their own array for D3 to use. Now that we have dissected the data a little, let's build a real array of objects that we're going to bind to. Because we don't really need the numeric values for mapping since it's assumable by index, we're just going to map all sales figures into an array of objects that has a month and sales property. The month property can leverage the index passed into the load-dash map to assume its value, and the sales will just come from the array value. Now that we have our data in a format that we can use, let's start building the graph. We'll define an array of strings that will represent the x-axis tick values. That way we see something meaningful instead of just 1 through 12 or 1 through 4, depending on the report type. Next, let's actually build the xScale object. The scale is going to tell D3 how to graph the value based on its domain, or in other words, like 1 through 12, and its literal screen size, so maybe 600 by 400, horizontally excluding margins. Next, let's build the actual axis based off the scale. Because we have a very specific set of data, we are going to statically define the ticks, so when we go from 12 to 4 data points, like monthly to quarterly, we don't have 8 trailing ticks of non-existent data. There are probably other ways of doing this, but it was really straightforward this way in this case. Next, we'll define the tick format. That's where we provide a real string value for the literal numeric value. Now finally, we're going to orient that scale to the bottom of its container and make it the x-axis. This is where that initialized boolean comes into play. If we're not yet initialized, we're actually going to build some new HTML elements by appending a graphics element and placing it accordingly with the transform style. If we are initialized, then we're going to actually just add a little animation and transition to the axis, because when the data changes based on the scale we built above, the call function will actually apply those changes. Now let's build the Y scale and axis. The code is starkly the same. The only differences here are the domain is based on the sales array, the range is vertical instead of horizontal, and is oriented left when placed on the page. Alright, now that we've provided all of the configuration for the graph, let's bind this thing to some data. Here we are explicitly building a line chart, giving it an interpolation algorithm, and then providing real data for each X and Y data point. Notice that the X and Y leverage the scale variables to send back a value. We're expecting an object that has a month in sales property, because we're going to bind it to the underscore data variable we built up above. Vertically, we need it to scale based off the sales value, and horizontally, we need it to scale based off the month or quarter value. Now take note, the interpolate call is very important. If you interpolate the values wrong, then the endpoint of the line will not match the vertical axis values. Alright, now we actually bind data to it and give it a bit of a transition, so when the data is changed, you get a nice animation. An important line is the D attribute, where we supply the value of the area or scaling and drawing mechanisms. Finally, we set it to initialized, and we are good to change back and forth between monthly and quarterly sales. Quarterly sales are done the same as monthly as far as the object return for graphing is concerned. The sales are just grouped by quarter instead of month. Alright, now that we know how D3 works, in our next video, we are going to be listing all unfulfilled orders in the system. This is a bit more the same as far as how you set up a list of data, but it's an important piece of an order fulfillment system, and so we want it on the dashboard. Now, in the last video, we really covered a lot of material. Just looking at some of those D3 statements will make your head spin. Don't worry about that. You're not going to be able to take it all in. Just remember that it'll look familiar as you continue to develop your knowledge in that library. Now, this is the third video in this section. And in this video, we're going to be covering some very familiar territory so we can get the rest of the dashboard built out. We're going to be building a new view for the unfulfilled order listing, a resource to recover that data, a controller to run the view, and finally hooking it up to the dashboard. We'll spend more time reviewing how we fulfill the data for the resource in this video because everything else is mostly a review. Alright, as stated in the slides, we're going to be spending our time dissecting how we are recovering the data for this view rather than walking through familiar territory with the view, resource, and controller stack. Now here we see a pretty straightforward process. Each order has a Boolean field named isFulfilled. All we want to do is return any order where that field value is false. Here we are leveraging the find many method of the server data model. This allows us to indicate what values fields should be for them to be returned. A nice little search feature, if you will, albeit not fully featured because there's no like comparison. But you get the idea. Now that we can recover the data, let's walk through building the resource. It's a very basic resource. It has a name for dependency injection and an endpoint. Here we see that it's going to be an element directive. It has a template for itself, an isolate scope, and then a controller that does two things. Loads all of the data from the resource and sets up some table options for data tables. As you might have guessed, it's going to leverage the sale list directive we built quite a while back. Examining the template, it doesn't get much easier than this. We've got a header, leader, and a sale list that is going to be populated by the controller. Adding it to the dashboard is now as simple as placing that element in the app template. And that's it. In this video, we covered building another dashboard component. We reused some concepts like a directive with its own controller. In our next video, we are going to be building the last block of the dashboard, recent orders. In the last video, we got a chance to take a breather and just hook something new up to the dashboard that was listing data. This is the fourth video in the section, and in this video, it's going to be a lot like the previous one, because we're just going to add one more listing to make a fully relevant dashboard. In this video, we are going to load up all recent orders. I wanted to do this one because it's a date-driven set of data and is thus common to most enterprise web applications. Alright, getting started by reviewing how we might recover recent orders in mock data. We see that we first only want to operate on unfulfilled orders. Next, we are going to leverage a library named Moment to handle the date manipulation. Moment is a very powerful date and time library that is absolutely essential for database applications, basing their data on date and time. Well, honestly, just about every application today. You can find Moment online at momentjs.com and download or install it using their instructions. Now, in this application, we installed it with Bower. As you can see, we are building what I'll call a pivot date, or in this case, the earliest we'd want data. With that date, we're going to actually leverage the filter method of Lodash to return a true or false to include or exclude rows, respectively. With Moment, the date comparison is really easy. If the sale date of the sale object is between the pivot date and now, include it. Now that we can recover the data, let's walk through building the resource. It's a very basic resource. It has a name for dependency injection and an endpoint. Here we have a directive that looks just like the one in the last video. The only difference is we are loading data from the recent orders resource in the controller. Examining the template, it's just that easy. We've got a header, leader, and a sale list that is going to be populated by that controller. Adding it to the dashboard is now as simple as just placing that element in the app template. And that's it. In summary, we covered how to build extensive mock data, building graphs with D3, and added the remaining components to the dashboard. At this point, it's time to start hooking up the backend. In our next section, we'll actually get this hooked up to the Node.js backend. Welcome back to a brand new section. In the previous section, we covered how to build extensive mock data, building graphs with D3, and added the remaining components to the dashboard. At this point in time, it's time to start hooking up the backend. This is the fifth of an 8-section course on the mean stack. Over the next 5 videos, we will be discussing how to model your Mongo database with Mongoose, set up routes with Express, hook up the API in Angular, and then add some data full stack. This is the first video in the section, and in this video we will be covering what a Mongoose model definition looks like, what different data types can be modeled, and how to model one-to-many relationships. Let's start with the simplest of all models, the customer. The first thing you'll notice is that there is a require Mongoose at the top. While this concept may be elementary in Node, let's review it quickly. Because this require doesn't start with a path, it's going to look at the Node modules folder for Mongoose. When it finds the Mongoose folder and loads the package.json file and looks for its main property to decide which JavaScript file to execute, it will load that file and execute it. Now, if you're not even sure what a module looks like and how to define one, just keep what I mentioned in the back of your mind and we'll review one later. A Mongoose model is nothing more than a JavaScript object that defines properties or fields and their data types. In the case of the customer, all fields are strings. However, there are clearly other data types available in Mongo, so Mongoose exposes those too. Here we see all of the optional data types. We'll get a chance to use Boolean and number later on as well. Alright. Remember how I said we'd review a module later on? Well, it's time, and we don't even have to switch files. A module in Node is nothing more than a JavaScript file. They're one-to-one. This file, customer.js, is a module. You see that statement there that sets module.exports to the result of the mongoose.model call? If we were to require this file right now with something like require./customer, whatever variable I assigned, that would be an instance of a Mongoose model. Later on, you'll see a module that exports an object with different properties. Looking at this model, we see a few differences. The first is that we are using new types like date, Boolean, and number for the fields. However, we also see something else that's different. We have defined items in an array of objects. This is honestly, to me, where the power of document databases come into play. Instead of building another table to reference the items to sale document, that's basically all there is to modeling in Mongoose. There are some other cool things that can be done like object ID references, but we're not going to cover those in this series. We will use those models later on, once we get to the APIs, so that we can perform CRUD operations against the database. In this video, you learned how to build a model in Mongoose. In our next video, we are going to be discussing how to set up routes in Express, so that data can be manipulated over a RESTful service. In the previous video, we walked through how to model collections in Mongoose. This is the first step to CRUD operations server-side with Mongo and Mongoose. This is the second video in the section though. And in this video, we will be covering how to modularize routes for maintainability, use the Express application for routing, and how to perform CRUD operations inside of those routes. Now first, let's start by how we might modularize routes. See, you could put all of the routes in one file, but that starts getting hard to maintain. Let's have a look at the customer routes. Before we go any further with the server-side code, I'd like to break down the folder structure just a little. It really helps modularize the models and API. In the root folder, we have files that load other modules for the most part. In the API folder, we house the API for each entity, as well as a shared CRUD module that makes CRUD operations with Mongoose easier for those API exposers. Finally, in the models folder, we house all of the model definitions for Mongoose. Now let's first review the routes themselves. In a minute, we'll get into what's required for the module. That's right, module. We're building another module. By now, you should start seeing how easy it is to modularize Node. The first one we see is a GET at API customer ID. This identifies the path of the URL that this function is executed on. One key to note here is that the ID part of this path is optional because of the question mark. Interestingly, because we specified a named part of the path, if an ID is supplied, it's accessible via rec.params.id when we get into the middleware. The next one we see is a GET for API customer ID sales. This one differs from the previous one in two ways. The first is that it requires a customer ID. The second is, of course, that it's a child path of the customer, you might say. This is going to return all sales for a specific customer. The last one we see is a POST to API customer ID, much like the GET as far as that ID is optional goes. This endpoint is for both inserting and updating a customer. Now take note, the POST verb is generally used for inserting data. Keep in mind, when building RESTful services, there are times combining both into POST makes sense. Some of those reasons include the simplicity of the server-side data model, reduction of separation on the client-side consumers, and others more related to your project. It's completely up to you. That is why the ID is optional though. Now, it's even possible we don't need the ID here for updating because we don't really use it. Internally, in the update method, we are looking to see if there is already an ID. However, this is a good pattern to follow, sending the ID, because that would allow us to patch the model if we wanted. We could add the _ID field before sending it down if it were missing, but existed in the URL. Alright, now that we've discussed what these endpoints are for, let's dig a little deeper into the CRUD operations. Let's start with the update method. This is capable of both inserting and updating models. The reason it works is because we create a new model at the top and then set isNew properly based on the _ID field. Those two statements are absolutely key. After that is pretty basic stuff. We call the save method and then leverage the callback. Now take note, by sending in the callback, we are letting Mongoose know it needs to be executed right now. In Mongoose, you could build larger queries by leveraging a Fluent API, and then after tacking on operations, you could call execute manually. Now let's take a look at the retrieval methods. These are real basic functions that leverage different ways of executing the same underlying function. You'll notice that they all call find. GetAll sends an empty object for the query. GetById performs a translation on the ID to a Mongoose object ID before sending that into the findById method of the model. And find calls the Mongoose model's find method but injects the query we provide. All of them send a similar response. Finally, let's have a look at send response. Now before we dig in, let's keep in mind that the idea here was to either send the response right away using the Express response object we injected, or if that res object is a function, in other words a callback, then we want to execute that callback with the response. Either way, It would all be encapsulated, so we could also centralize the stripping of Mongoose model fields and just return basic JSON objects. Breaking it down, we see the first branch handles errors, sending a consistent response. The second set of branches determine what to do based on the response object. If it's an object, then we have some more decisions to make, because it's either a single object or an array. Otherwise, if it's a number, we need to send that as the status. Finally, if it's neither of those, possibly just null, then we'll just send a 200 assuming all is well. Back to the object branch. The first branch inside there is just handling stripping down the Mongoose models to true POJOs, bearing in mind that it's safeguarded just in case the toObject method doesn't exist. Next, it evaluates that res object we aforementioned. If it's a function, then it executes the callback. Otherwise, it executes a satisfactory 200 and sends back the response as a JSON payload. Alright, a lot of other endpoints in the application are just much more of the same, but I did want to show you some more complex query logic and how you'd handle it. Examining the process for recovering monthly sales, we get a chance to see where we deviate from the CRUD library and leverage other Mongoose APIs. You might remember the idea behind the monthly sales is grouping all sales, summed by month. Doing this in Mongo is much different than basic array manipulation client-side. The first thing you'll notice is that we use the method aggregate. Think of Mongo queries like a pipeline. You're going to tell Mongo to take the documents, do this with them, then that, and then this, and then give them back to me. Here we are saying first unwind or flatten out the items field for each sale object. That being done, we can do some basic grouping. We're going to group by the month of the sale date, and then inside that grouping, with the total field housing the result, sum up the result of the quantity times price for every item in that sale. This will give us a very nice grouped sum. We have a little more work though. If we don't have data for a specific month, we need a default value of 0 to be returned. To do this, we are going to leverage the defaults algorithm of Lodash. What it's going to do is take the zipped object we provided and compare it with the static one. And if there is a key missing in the zipped object, it's going to take that default value. With that done and out of the way, we will now simply leverage the CRUD module to send a response. Since it's nice and wrapped up in that method, it will ensure the response is consistent, objects are stripped to POJOs, and even ensure errors are handled if there are any. We have now been able to set up the routes. Great job. In our next video, we are going to be covering how we hook up the API client side in Angular. A little hint. All it takes is to stop loading the ngMox module. In the previous video, we really went in depth server-side discussing how we build routes and respond to those requests like any other RESTful API. We even got to dig into how we use Mongoose and those models and perform CRUD operations on the database. Now this is the third video in the section, and in this video we will be covering what it takes to get AngularJS talking to the server. Here's the cool thing. No code is going to change. I know, that's insane. But that was the entire idea behind the backend-less development model. What you will get to see is just how we get to connect to the server instead of going through the mock backend file. This means you're going to get to dig into Grunt quite a bit. Before we dig into the code to do what we want, let's discuss the concept behind the mock data in more detail. We wanted to be able to use mock data when a backend wasn't available. Anytime you build something like this, you want to make sure the code necessary to turn it on and off is automated. You also need a system that is interception driven, a system where I can use the same code for offline and online access when it comes to controllers, directives, services, and more. So what do we know about our access method for online transactions? They go over HTTP to a RESTful service. This is where the ngMock E2E module came in. That's actually what's used when doing E2E testing and when testing HTTP calls that go through the $HTTP service. With that in place, we know we can intercept calls that resources make because they simply leverage the HTTP service underneath. This now means that controllers, directives, and services accessing data don't even need to worry about how they access data. They could even use a custom library like REST Angular if they wanted to. The only requirement is that it uses the HTTP service to get the RESTful endpoints. This makes our solution very agnostic. This also means all we need to do is write similar code to what we'd write in a unit test to intercept every HTTP call. Then, leveraging the server data model as storage, we are now just writing an API against an array. There is one more hitch in the get-along though. We need to be able to turn it on and off. You've seen the mock backend and server data model code. Now let's turn it off. The easiest way to turn it off would be to exclude the AngularMox library. Easiest way to do that would be through Grunt, since it builds the dynamic index.html file. The first piece to this puzzle would be to conditionally load the ng mock EDE module. Unfortunately, AngularJS won't fail silently if a module listed in its dependencies can't be loaded. That'd be an awesome feature. Until then, we need a little helper. That's what this try load mock EDE method does on the app object. This is why we have a bit of a framework wrapped around our module declarations. See, we have the ability to manipulate the dependencies array before actually defining the module. Looking at a module declaration, we see this at work. The first line here builds the absolute required dependencies for this module. The second line tries to load the ng mock EDE module. If it's there, that means we want mock data, because if it loads HTTP calls, aren't going to go through. If it's not, no big deal. Then we load the module. If it's there, we hit mock data, otherwise we hit real endpoints. Now we get to dig into some pretty gnarly code and see how some of this automation really works. Starting off, I know three things. I want grunt mock to build an index file for mock data, and I want grunt to build an index file for real data, and I want grunt dist to build a distribution. We're not going to talk about the third right now. Let's start with the grunt default command because it's the basis. Building these automated script includes is not as straightforward as you might have hoped. The primary lifter is the index multitask. Upon examination, we can see that it's leveraging the built-in file source variable to determine what files are included in the build. Then we're going to do a basic file copy, but we're going to manipulate the contents. Now take note, the file source array is loaded during the configuration of the grunt task. In this case, the index task. This is fully automated by Grunt. Looking at the index task configuration, we see that in the build state, or the default state, we do not include any mock files like Angular mocks or mock backend. A little pro tip as well. The order here is the order they will be included in the array, and thus the order they will be loaded in the index file. There are times this won't matter, but there are times it's very important. We're going to change the content of the index file because it has two places to insert references, for CSS links and script references. We are going to focus on the script references here. Drawing your attention to the for each. I want to draw a line between the scripts reference there and the scripts reference that were set in the JS files array in the grunt script. These are directly related. This is how we are able to add any new JavaScript files into the index automatically when we detect changes with watch, like new, updated, or even removed files. It's dynamically based off of the file system at that very moment in time. Now to get this to load a different set of files, we need some different configuration. That's why we have a mock section. You can see this looks a lot different. It's the same concept, but I do want to walk through some gotchas. First, let's define globbing. It means we are defining dynamic file paths with wildcard characters. Specifically, we may be including or excluding entire folder structures, hierarchically, or with our glob patterns. When globbing files, you want to keep in mind that it's linear. Let me give you a concrete example. Let's have a look at the mock.files list. Here you can see we include three files: Angular mocks, the most important piece of the puzzle, chance to build mock data, and mock backend to intercept the HTTP calls. What's interesting though is you see at the very end, mock backend.js included manually. What's the purpose for that? Examining app_file.js, we see a very important statement, not source/app/mock backend.js. Because this is linear, the file gets excluded when this executes. So it was included at first, then excluded. So we need to include it again, or it's not going to make it to the index file. This can happen when order matters because globbing patterns can step on each other. So why even have the mock.files array? Well, there are other tasks that need it. Take for example the copy task. We always want to copy what's in the default task. But when you run grunt mock, we want to also copy those files into the build folder, or they won't be able to be loaded by the index file even if the script tags existed. This is where the build tasks can get tough. Automation is never easy because it has to make a lot of decisions, but even more so, assumptions. Okay, so the last piece is how do we get these two different tasks? That's not too difficult. We just need to chain a few things. Examining this code, we see three different tasks that really boil down to the two we want. We are indicating that the default grunt task is comprised of the build task, then the concurrent :build task, which loads the node server and the watch tasks. Then we see that the build task is comprised of an array of predefined tasks. We'll get to that in a minute. Reviewing the mock task, we see that it's a union of a set of predefined tasks as well as the concurrent:mock, which starts up the node server and the watch tasks. The difference here is that we need to watch a new subset of files, because if we change mock backend or server data model, we want it to live reload when we mock. Examining the two lists of predefined tasks, I want to point out one thing. This is how we run both copy build and copy mock. For example, when we are executing the mock task. Time does not afford us to continue going down this rabbit hole because there is a lot more to Grunt. But this code is what was relevant to how we turned mock data on and off. And I think finding out we didn't have to change any code at all for the client was a very nice effect. Excellent. We hooked up the API and you got to dig into Grunt to learn how to turn mock on and off. In our next video, we are going to be adding a customer full stack. In our last video, we really covered some pretty gnarly stuff related to how we turn our backend-less mock data strategy on and off using Grunt and conditional dependency loading. This is the fourth video in this section, and in this video we will be covering how we add a customer in the system, what's actually happening when a request is made, and be discussing some of the details of Express and how it works. If we navigate to localhost:3444 in our browser, we see our dashboard. Clicking on New Customer in the menu will let us add a new customer to the database. Filling in the details and clicking Save Changes will add it to the database and take us to the All Customers screen so we can see the new customer. Now that we can see the code is ready and working, let's kind of explore what happens behind the scenes here. Let's start with the Save Changes. Looking at the customer detail controller, and specifically the VM save function, we can see the entry point. The model here is an instance of a customer resource. Executing the save method tells it to execute a post to the default endpoint. Because there is no _ID on this object, since it's new, it's going to execute a post against API customer and send the object as a JSON payload in the body. Now let's move on to the server. A little pro tip, having the developer tools open in your browser will allow you to track network traffic. This will aid you in visualizing the aforementioned. You will be able to see the post request and the body as well as the response from the post request. I want to focus on the middleware line for the body parser. What's happening here is we are telling Express that we wanted to send every single request through the function that's returned from the body parser.json call. This is probably, for some, your first introduction to Express middleware. First, what is middleware? The idea is that when a request from a client comes into the server, depending on the endpoint, there are operations that need to be performed. These middleware operations perform an order of registration that is absolutely paramount to debugging issues in your API. Each middleware function has the option to send a response to the client and end the request, modify the request and response objects for middleware further down the chain, and even call next, indicating that the next middleware in the chain should execute. Little pro tip, keep in mind that they are executed in order of registration, i.e. app.use. And so if you ever have something running out of order, or you have an API endpoint processing the request when you didn't expect it to, you probably just have it out of order. Also note that this is a benefit. By ordering your registrations based on traffic, you can drastically improve the performance of your API when necessary in production. Alright, back at the ranch, we see that we are executing the registration prior to calling the API registrations. This specific middleware module is built to parse the body of a post or put request, deserialize the JSON into a POJO, and then attach it to the request object with a property named body. This means further middleware can now grab the payload simply by referencing rec.body. Alright, moving on, let's look at this next call. We are executing a function that was exported by the API module and injecting the Express application. Upon closer examination, we see that it's going to do a few things. First, it will build an endpoint at API and return the text the API is online. I always do this just in case I need a health check. Doing this in your browser gets you the expected outcome. Now let's zero in on the require./API/customer, which then calls a function and injects app. That's the module we reviewed earlier in the series. This is where the customer CRUD operations happen. Okay, cool. So now you better understand the app get and app post commands here. They're adding middleware. So this save we executed, the next piece of server-side code to execute will be the app.post, we've registered. This is why the ID was optional in this route. When adding a new customer, it wouldn't break here otherwise. Now, because we have a nice set of code handling the integration between objects and Mongo leveraging Mongoose, all we need to do is execute update. Remember, it's going to send the response to the client for us. Now take note, this is the very same path that is executed when a customer is updated. The only difference is there is an ID with the payload, so the CRUD code knows it's not a new entity. It can be argued that this is not a RESTful API. This is more of an ideological discussion. There are numerous APIs on the market today that do not leverage a put request. As stated before, this is completely up to you. I did not leverage the put because of the simplicity of the model server side and the ability to reuse this $save client side. Great, we've successfully learned how to add a customer to the system. In our next video, we're going to be adding a sale full stack. In the previous video, we covered a ton of ground surrounding Express, how it works, what middleware is, and I hope you also noticed one other thing. There wasn't any real large sums of code to write when we wanted to tie the server to the client. See, the vast majority of the code is on the client. Node is only being used as an API, and so that means by definition, it should be very lightweight to handle huge request loads. This is the 5th video in this section, and in this video we will be covering, for the most part, just the server-side code for adding a sale. It's going to look a lot like adding a customer, not surprisingly, and we are of course going to add a sale to a customer. Alright, so let's just dive right into the server-side code because now we know how it's all working and tied together. Focusing on the export for this module, we see that we add in 2 more middleware functions. One to handle getting all or specific sales, and one for inserting and updating sales. That's it. There are no real complexities involved here. Because this video is mostly just reviewing concepts we've already tackled, I'd like to take the chance to talk to you about 2 things: a jointly fit stack and a framework. You see, I've built applications on so many technologies and stacks I can't remember them all. From DOS Fox Pro and Visual Fox Pro to .NET and Mean. I've seen languages and technologies come and go. What I've never seen, until I met the Mean stack, was a stack so jointly fit together. Everything from the database to the client is built on JavaScript and POJOs. Honestly, the cost savings alone to having your entire team running on the same language is phenomenal. I want to take this chance to also make known that Node is not good for everything. When it comes to heavy processing operations, it fails to perform. The reason is simple. JavaScript is a single-threaded animal. That's why everything works on callbacks and what are called ticks. Think of the execution engine as a huge queue. You add commands to the queue, and when this tick or flush of the previous queue is done, it's going to execute the next. This is why Node can handle millions of requests. Why does heavy processing hurt it though? Simply because you're blocking the thread while processing something. I said all that so I could say this. I love the Mean stack, but it's not a golden hammer. It is quite possibly the perfect stack for almost every web application today, especially consumer applications. It is not necessarily the right stack for enterprise applications of every imagination. I wanted you to know that I was not disillusioned to this reality, even though I promote the stack heavily. But the trick is that today's applications are componentized, and so the more those components share in common, the easier and faster they are going to be to work with. Keep that in mind when architecting your next solution. Now take note, other processor-intensive operations can be performed in other technologies like .NET, Java, and more. Those can communicate with the Mean stack you've built via RESTful services or even queues like Redis in larger enterprise environments. And now a framework. While there has been very little code written to get it so we could perform CRUD operations on customers and sales, a huge amount of code is baked into the solution framework this application sits on top of, from Grunt to module loading and encapsulated CRUD operations. This code is what makes it so fast to build on. Keeping that in mind, the framework I've put forth here is my opinion and not a prescription. I believe I've found the right solution framework for me, and I too think it's the right one for you. There are a lot of options out there, including scaffolding frameworks like Mean.js, but I think they all make too many assumptions. In this framework, I've tried to only make necessary assumptions to allow the stack to float. What if you didn't want Mongo? No problem, you can switch that out. What if you didn't want to use resources, but rather REST Angular? No problem, the backend-less development scenario is agnostic. But I digress. Let's get to the demo. If we load up our application in localhost:3444, this gives us our dashboard. Navigating to New Sale on the menu will get us to where we can add a new sale for an existing customer. Filling in all the details and clicking Save Changes will take us to that customer's sales page so we can see the new sale. In this video, you saw how you were able to add a sale full stack. And in this section, we covered a ton of ground, especially in terms of understanding how this works full stack and our backend-less offline mock data strategy. It's really all coming together. While there were a lot of fundamentals to go through, I hope that by now, it's all really starting to make sense. I look forward to seeing you in the next section. In our next section, we'll talk all about how we can automate some of our testing story and get further involved with Mocha and Jasmine. Welcome back to another section of learning web development with the Mean Stack. In the previous section, we covered a lot of ground, especially in terms of understanding how full stack development works and our backend-less offline mock data strategy. It's really coming together. This is the 6th of an 8-section course on the Mean Stack. Over the next 5 videos, we are going to be testing machines. We will use Mocha, Chai, Jasmine, and Karma. This is where we get to harden our application. This is the first video in this section. And in this video, we will be discussing how to build a spec in Mocha to test a route and how to execute our Mocha tests using our custom Grunt task. This is the spec to verify the customer routes. Remembering the convention that, if built properly, a spec can cleanly define what a file can do by reading the test output. Let's have a look at all of the specs. A spec is defined with a call to the global it function. Here we see that our test suite, a collection of specs defined by a call to the global describe function, indicates that our SUT should be doing 3 things. All right, how are we going to do that? Well, I'm sure there are a lot of ways to skin this cat, but we're going to do what I believe is the easiest. We're going to mock the app because the system we're testing will be registering these routes with app.get and app.post. It exports a very simple module in the form of a class. This means we'll be building a new instance of this app. Notice it mocks the methods that might exist on the Express application object, and those methods simply store those registered routes in an array. Since the array is public, we can use it for verification. Back in the spec, we can see that at the top of the file, we are requiring the mock app. After requiring it, we are building a new instance of the class that's returned to us, or exported by the module. Then we require the customer API module and inject the mock app as we built it. This means that when the customer API executes get or post on the app it received, the app object is going to be capturing those registrations. Now take note, there are other ways you could have captured these registrations. Instead of a simple array, you could have had an object with multiple arrays, one for each operation. But in our case, we just didn't need that much overhead. Now that we've executed the customer API module, it's time to verify we registered all the expected routes. That comes in the form of an expect. Here we are going to pull off a registration and make sure that it's equal to what we'd expect based on the SUT. With that complete, let's actually run these tests. Because we need to execute these tests frequently, I've built a custom task in Grunt just for running Mocha tests. First, we need to make sure that Mocha is installed. Execute this command to install Mocha globally. Focusing on the custom tasks at the bottom of the file, I'd like to draw attention to the im task. It's very simple. It just executes the Mocha CLI configuration. Looking at the configuration for that module, we see some very basic stuff. The reporter set to spec is important because it's what causes our specs to output the name of the it function and its success or failure. The bail is also important. Right now it's set to true. That means that if there is an error in any of the files, it's going to stop processing tests. Finally, it provides an all property. This is the location glob for all of the spec files. It's pretty simple because they reside in the Node applications folder directly, so we'll just include server, all of the subdirectories, and search for all spec.js files. Those files will be executed and are expected to be tests. Now that we understand how to run our Mocha tests, let's do it. From the terminal, we are going to execute this command and see the output. Thankfully, all of our tests pass, and so we have no failures and nothing but green checkboxes. A similar set of tests will be written for the dashboard and sale APIs. Now great, this brings us to the end of the first video. We've now tested our app using Mocha. In our next video, we are going to be discussing how to test the server-side API. In the last video, we talked about testing the routes. While the API and routes may seem to overlap, they do differ. Making sure that each endpoint exists to spec is very useful. It ensures that the endpoints you publish will in fact exist. This is the second video in this section, and in this video we will be covering just what it means to test the API instead of the routes. And we will be reviewing and building some tests that actually test the API. This will all be done leveraging Mocha and Chai, because we are server-side in Node. I alluded to this earlier, but there is a distinct difference between routing and the API. While the API is accessed via RESTful routing, there are other ways the same API might be consumed. In this example, we have not built out any of those, but that's how we want to look at it. Now, we're going to actually test the API. This means we want to make sure that if we request the data to be retrieved or manipulated, that it works. The question becomes, just how are we going to do this? There are a lot of options out there, but we are going to roll our own mocks and leverage a library named proxyquire. This library allows us to intercept the require calls and replace the returned module with our own. It's actually going to get back a stub while we're testing, something we have control over. See, when our set API customer loads /models/customer, we are going to force back mock model. Same with /models/sale. This is how we gain control over our test. Before we can write tests, we need to know what working is. How do we know the set, the system under test, is in fact performing as expected? In our case, we're going to be testing two different types of endpoints in the API, get and post. This means that we are either retrieving data or manipulating it. With that defined, now we need to know how we're going to be sure it worked. The best way to test this API is to capture the response. If we capture the response, it's at the end of the line. It's the response we care about anyway. If we ask it to get some data, we want to make sure it returned the data properly. To capture these responses, we are going to build a few mock objects for ourselves. We want to mock the app, response, and model objects. We need control over one of the objects because it's a dependency of the API, the Express app. We've built this mock to give us that control. With this mock, we will be able to capture what routes exist as get and post, as well as execute their implementations so we can test them. Take special note to the logic in the get and post method stubs. The route is pushed on to the overall routes array. Next, we built an object that houses the route and its callback. And finally, we push that onto the proper callback array. In this case, the get array. This work is going to allow us to do two things. Verify that a route was registered. That's necessary, and we covered that in the previous video. And allow us to execute those routes, taking note to the code inside the execute get function. Now here we see some basic array work via Lodash. So we find the appropriate callback for the route we wish to execute, and then an execution of that callback. I would like to draw your attention to the apply function. This is a really neat function. By calling apply on the callback function, we're actually able to call it with the arguments injected into execute get. This also means we don't need to know what the callback signature looks like. We just need to make sure we send the arguments the caller sent, less the route because that was the first parameter. That's why we're slicing the array-like object starting at the first index. With this mock in place, let's move on to mocking the response object because that's how we're going to inspect the response. This one is even cleaner. In this case, we're just going to mock up a few functions and also allow ourselves to store that response and its corresponding type if necessary. We had to mock up the log client object so that logs can be sent in case of error. We mocked up the status function so that we can test and verify a numeric status response. We mocked up the end function because that's called after executing the status function. And finally, we mocked up the JSON function because that's how we'll inspect real responses. Alright, now moving on to the very last piece of the mocking puzzle, the model. This is going to be a mock of a Mongoose model. Remember the proxyquire library mentioned earlier in the video? In short, we just need to mock a few methods: find by ID and remove, and save. Effectively, the goal here is to capture the response so we can interrogate this object later during assertions. The key to any of these methods is to simply return to their callback an expected response. That response is set through the setResponse method before execution during testing. You'll notice it works a lot like the execute_get function, in that it leverages the built-in arguments variable here. But it doesn't have to leverage apply because the callbacks being injected are very well known since we rolled this for our own framework. At this point, we've got our dependencies mocked up and we're ready to test this API for real. Looking at this module, we see that the res is just injected into the CRUD module in every place. This means we need to dig a little further to see what we need to implement for the response. Before we go, let's take note that we leverage getAll, getById, find, and update on the CRUD module. Looking at getAll, the res isn't used until we get to send response. Moving on to getById, we see the same thing. It looks like find is the same path and update, while it has a couple of branches, is the same thing. Let's keep moving on to send response. So there are a few different uses here for res. The first one I see is for the log client.log. This means we'll have to implement that. It also calls a function named status, and then subsequently one named end on the result of the status call. We'll need to implement that chain. The next one on the list is that it's called as a function. This is used when we don't inject the real response object, but want called back. We won't be worried about that. We see that it calls a member named Jason. We'll need to implement that one. As far as handling the other branches where it's looking for a numeric response or an empty response, we don't really need to test those here because it's not going to be a path for our set. These should be tested when testing the CRUD module. Remember, when testing a system, you want to make sure you keep it isolated. This means that you don't test other systems in the meantime. If those branches need to be tested, they need to have their own set of tests because we're really testing the customer API. As you can see, this is a pretty simple mock. The nice thing here is the response type and response are added dynamically so that they'll be undefined if nothing happens. That's going to make assertions easy. With this mock object in place, we're going to need to visit a little more work on the mock app. The key I want to point out here is the registration of the callback and the execution of that registration. Both get and post work the same here. We are going to register the verb-specific route and its callback. Now, if we want to actually execute that callback, like if the user hits the endpoint, we just need to call the verb-specific execute with the route we want to be executed. You can see that we've done this in the execute get and execute post methods. The apply that you see here is so we can actually inject the request, response, and next parameters when we execute the get or post request. All right, now that we have all of the necessary mocking and support in place, let's test the API. Let's start with the simplest of operations, getting all customers. Here the mock model is leveraged to set a determined response. Then we execute the get operation where we do not send an ID, so we're going to end up executing the find method against the model with an empty where clause. Remembering the mocked find method, we're going to return an array of customers. Now that we have control over the response, let's verify it with assertions. First, let's make sure the response type and response are not undefined. We expect them to be JSON and an array of customers respectively. This is what testing the API is really all about. The same concepts work for updating as well because we leverage the same deterministic response types. I'd like to highlight one other test, and that's where we actually cause an error. Now take note, stubs are a helpful tool when testing. In this case, we are building an anonymous empty function. We don't want anything to happen if it's called. There are many other options. By setting the rows affected to 0, we are going to force the update method on the CRUD class to throw an expected error. This will change the response type to log because we set it that way in the log client.log function. It will also set the response to the error sent in. Great! In this video, we covered complex server-side testing with our own mocks, proxy choir, sign-in, and chai. This was a deep dive, and you made it. In our next video, we are going to be moving to the client side with our testing, and we'll test the API in Angular. In our previous video, we talked about testing the API server-side. This was really a pretty complex process because we had to mock up quite a bit of stuff. The server is harder to test because it has so many more dependencies in the form of integrations, like Mongo. This is the third video in the course. In this video, we will be covering how to build a test that will test the API in Angular and also discuss how similar testing the API is to mocking the API. This is going to be a standard Jasmine test file for all intents and purposes. We are going to have to describe how to wrap up our API tests, and then inside, we will have its that wrap up each test. You are going to get a chance to see the use of the $injector service to clean up loading dependencies and we'll be leveraging the HTTP backend service again. This is where you'll start to see it's similar in nature to the way we mocked up data. I'd like to start by focusing on the two before each uses. The first one is going to ensure that the customer module is loaded before each test runs. The second is coupled with the variables we'll be using later because we are going to load the dependencies we need for each test. In this case, we are testing the customer resource, and we'll need to write HTTP backend service so we can mock responses and such. Digging into the first test, we can see an expect get. This is going to queue an assertion that is later used to verify that all expectations, if for example RESTful calls, were fulfilled during the test. It also defines what data to respond with. Next, you'll see that we actually execute the query function of the resource. This alone does nothing. The next statement that calls flush is what forces the promise inside the resource to be resolved and sets the result. You want to think of flush like the response from the server. Finally, after issuing the flush, it's time to verify the results. Pretty straightforward stuff. First, we want to make sure that the result isn't undefined. If that passes, let's make sure it's an array with a length of 2. Finally, let's verify the name of each result to ensure it's the array we expected it to return. There is one more piece to this puzzle though. We need to make sure that our API expectations were fulfilled. We are going to do that with the after each function. These two methods verify the expectations that were submitted with expect-get and expect-post to ensure that our test did in fact meet expectations. These are important methods when testing the API. Now, the similarities between this test and the mock code we wrote earlier are not surprising because the mock code leveraged the HTTP backend service as well. There is one difference though. The mock code leveraged the when methods instead of the expect methods. If we look here, you'll see it uses when get instead of expect get. That's because the mock code is responsive rather than assertive. Other than that, it's the very same concept. Fantastic! In this video, we tested our API in Angular. In our next video, we are going to be testing controllers in Angular. In our previous video, we discussed testing the API in Angular. That really boiled down to testing the resource. This was also another solidifying argument for how mocking data client-side is leveraging the basic Angular testing framework. This is the fourth video in this section, and in this video we will be covering what it means to test a controller, as well as seeing another usage of the HTTP backend service to verify the controllers are working properly. Testing a controller in Angular can be done a lot of ways, but I prefer more of a behavioral test than a unit test. Unit tests mock all dependencies, and that can get very daunting in controllers. But behavioral tests will only mock what's external, and then verify the outcome. Let me give you a more concrete example. We're going to be testing the customer list controller first. If we look at the controller, we can define its behavior. Here we see the most important part of this controller is to call the customer.query, to which it sets the data source property of itself. That's very testable. Let's have a look at our test file. There are a lot of similar concepts here that were used in the previous test. The module is loaded with the before each, HTTP backend is loaded with the injector, but there is also this new $controller service. This exists to allow us to load a controller. When loading a controller, we need to use this service to build a new instance of that controller. Here we are going to load the customer list controller and not worry about fabricating any injectables. If we wanted to build a unit test here, we might fabricate the customer and the DT options builder injectables. Now we can get to testing. Looking at our test, we see a lot of similarities again. We see an expect get, flush, and then standard assertions at the end. There are some subtle differences though. You'll notice we don't invoke anything. This is because the controller was invoked when we grabbed it from the $controller service. The controller has already been executed. Keep that in the back of your mind because it will help you later as you debug testing issues. That's why we just need to execute a flush. Now the assertions are slightly different too, in that they are interrogating the customer list controller object. That's because the data source is set on this in the customer list controller, or in other words, the instance of itself. This is where you start to draw a line between the controller and the view, if you hadn't already. When a controller is used via a route, or even the ng-controller directive, a new instance of that controller is created, just like we did here. In fact, it's created with the $controller service. This is some pretty awesome stuff. Let's get into a bit more complex example. Let's test the customer detail controller. This test suite is still very similar to the previous, but it does have some subtle differences. The first is that we don't build a controller in the before each. because we have some different states the controller can be in because it handles both add and edit. To support this, we've built a getController method that allows us to instantiate it in a specific way. Here we see that we are actually injecting a specific value for the $state dependency. This means that all other dependencies will be injected as usual via the $injector service when the controller is built, except the $state dependency. It will have whatever value we provide. The important pieces are what is the current state and what are the params. And we also want to spy on the go method so that we can make sure it's called when we save a new customer. Testing the add state is pretty straightforward. Here we are going to simply ensure that isAdd, operation, and the model are in a state we'd expect if you hit the add form. The name property shouldn't exist, for example. Testing the edit state is just about as straightforward. We just need to flush out the HTTP backend so that the call to get the record works. Looks pretty familiar, I'm sure. Testing the save method is the new one here. We are going to leverage that spy on the go method to ensure we navigated to the customer state. Excellent. We tested our controllers in this video. In our next video, we are going to be testing Angular services. In the previous video, we tested some controllers. That introduced some new concepts and ideas that really start giving us a foundation. This is the 5th video in the course, and in this video, we will be covering what it means to test a service. We're going to get a chance to see how we leverage the $provide service to provide a value for a service we can't inject on our own like we did for the controllers. We're also going to see a couple of examples on spying. Testing the service can get messy because they tend to have a number of dependencies. This is where I differ from testing a controller. As I mentioned in the previous video, a unit test is where you mock all of the dependencies so you have absolute control. In a controller, it just doesn't make as much sense. But in a service, it's often a lifesaver. We're going to be testing the $history service. This service has one dependency, $state. We're going to mock that out so we have complete control over it. Looking at our tests, we see a lot of familiar concepts. One that is not is the use of $provide when loading the module. You may or may not know, but there is a shortcut when loading a module in Angular where you can configure providers without using the module.config method. It's the third parameter in the module definition. This mimics that. Specifically here, we are going to force a very static mocked value for the $state service dependency. That object is going to noop the go method. By having a mocked object that noops, or no-ops, a function, we can now spy on it and ensure that there are no side effects. The first test we can look at is very straightforward. Here we are just going to leverage the push function to add a new state, and then we are going to validate the all array. The reason there are 2 states in this array instead of 1 is because we always have an initial state because of our common JS module run. It also sets up the watcher for $state change success, ensuring that we always push new states onto the $history service. The next test is where we get into spying. Here we're going to test the back method. We want to make sure that when we call back, the history.go function is called. But we also want to make sure it calls through, because that should then call the $state.go method to go to the home state, because we only have the default state on the array. After we've executed back, we can now ensure that state.go was called with home. Wow, that was a great chance to see how spying works. In this section, we covered quite a bit of ground in the testing arena. Testing is a very subjective conversation. There are so many camps out there, you've got to find what works for you. As I've stated before, the real value comes in with regression tests as far as I'm concerned. I'm not saying building tests up front isn't useful, and I'm not saying TDD is bad either. I'm just saying that while a code base is in major flux for development, things are changing so quickly that tests just aren't solving problems most of the time. In contrast, when you're in beta or production and you find a bug, building an automated regression test adds huge value to the codebase. This automated regression test will ensure that you won't roll back the bug fix. In the next section, we're going to talk about deploying our application to Heroku. In the previous section, we really nailed down the remainder of what it means to test our applications in an automated fashion. We also discussed how the testing story can become very subjective. Good luck in your adventures in testing in the future. This is the 7th of an 8-section course on the mean stack. Over the next 5 videos, we will be walking through the process of digging into Grunt distribution scripts, deploying our application, and Node process variables. This is the first video in this section. In this video, we will be digging deep into the difference between build and distribution tasks in Grunt. To start off, let's get an understanding as to why we have a distribution task. The application is running fine under the build task. We must, however, consider that in production, we have resources to manage that do not exist in development. One such resource is bandwidth. While seemingly unlimited, it is not without consequence. On the side of hosting, it often costs per gig. On the side of the consumer, we must consider mobile devices. Request load is another such resource. On the side of hosting, the more requests made, the larger the load to handle, the higher risk of failure. On the side of consumers, applications that are too chatty cause issues again on mobile devices. To solve these two resource concerns, we do two things: concatenate all like file types into one and uglify those files. These are primarily what we'll spend our time on in this video. Now take note, there are times it's not possible, or far from convenient, to include files into one. I've left one such example in the codebase. It is importing our vendor CSS file for data tables. Let's first highlight the tasks that occurred during the build task. We've seen this before. This is important because the first task in the distribution is the build task. After the build task runs, we copy a few required assets into the dist folder. We have one vendor CSS file that I mentioned before. We also have some images and fonts that are required for our application to run. These will be the only requested files outside of our concatenated and uglified CSS and JS files. The next task is concat. This will build a single file for all JS and CSS files respectively, except for the one CSS file we copied to the dist folder. The next task is ng-annotate. This is going to take our single JS file and set up all Angular injections so they are not broken when uglification occurs. Remember that Angular injection is name-based. We cannot afford uglification the opportunity to change the names of the injected parameters on injectable objects. The next task is uglify. This is going to take the single JS file and perform uglification or minification. It will change variable names to single character names, remove all the white spaces, comments, and more. These settings are all configurable, but the defaults are acceptable. Little pro tip: if you're having trouble with uglification, the file maybe isn't compiling, uncomment the options section to beautify the file. This means that you'll be able to read it and determine where the issue is. The next task is less dist. Now, this is going to take the built main.less file, compile it into CSS, compress it, and drop it in the distribution folder. The compression step does not occur during the build task. Finally, the last task is index dist. This is going to build the appropriate index.html file based on the files that were included in the distribution folder. In the end, that becomes just 3 files. Compare that to the greater than 20 files required during development, and you see why distribution builds are important. This was a great video on distribution builds and understanding why they're important. That brings us to the end of this video. In our next video, we are going to be discussing how to publish your code to Heroku. In the previous video, we discussed what it meant and why it was important to have a distribution build. This is the second video in the section, and in this video, we will be covering what it means to deploy to Heroku, how to set up the remote for Heroku and WebStorm, and just how to publish that code to Heroku and what it looks like. Let's first start by understanding that Heroku is built to serve and run Node applications. This is also known as PaaS, or Platform as a Service. With this in mind, it makes deployment easier because a number of assumptions are made. It also means that they have great tools to interface managing those applications. Deploying your application to Heroku means nothing more than hooking up to a remote Git repository, one that exists for your Heroku application, and pushing a functional Node application structure. In our case, this means the package.json file and the server and dist folders. The package.json file is very important because the Node modules are installed during publish. Before we do anything with Heroku, we need to make sure this is a local Git repository. You can do that by issuing git init in the root folder. Now we need to log into our Heroku dashboard and click on the Node.js Getting Started guide. After clicking I'm ready to start, you get the chance to download the Heroku tool belt. You want to go ahead and do that for your platform. On the same page, we see the instructions to authenticate through the tool belt. That's the next step we want to take. The next step is to build a Heroku app. We are going to do that by executing this command. Now we are going to add 3 different items to the repo: package.json, server, and dist. by using these commands. Now that we've added them, let's commit them by issuing this command. After we've committed them, we can now push them to Heroku with this command. This will not only push the code into the Heroku repository, it will install all Node modules and start up the application using the script section of the package.json file. You'll notice that we are indicating it should start the server.js file in the server folder. This is going to start our Node server, which is going to use our static route to determine where to serve the client-side files from. We will get into that a little later before running our application. For now, we've deployed our application and code, and it's time to move on. In our next video, we are going to show how to set up the database in Heroku. In the previous video, we discussed what it meant to deploy an application to Heroku, and we did so. This is the third video in this section, and in this video we will be covering what a Heroku add-on is and set up a database in the cloud for our application. We will also take a look at an automated environment variable that gets created to allow us to connect. A database application cannot operate without a database. Locally, we connected to our own Mongo server. This won't work in the cloud. We need a solution for production. This is why I chose Heroku. It has this concept of add-ons. This means that we can add on functionality from different services and technologies without having to deal with connectivity and infrastructure. In this video, we are going to set up our database. This is going to be very simple. Simply executing this command will add a database to our account and connect it to our app. You can find more documentation on the add-on and pricing for more production-ready infrastructure online. With that complete, if we go to the settings of our application on Heroku and click Reveal Config Vars, we will get to see what was added. The Mongo lab_URI environment or process variable is referenced in our configuration. This allows us to use a local host string while in development, but does not require us to change anything when we go to production. Believe it or not, that's it. We now have a database. Let's have a look at it. If we click on the Resources tab of our Heroku application, we can see we have something new, Mongo Lab. If we click on that, it brings up an interface where we can see our Mongo Lab connected database and its collections. Right now there are no collections. When we first connect and start saving data, those collections will show up. A good resource for service-based application architecture is the 12-factor app documentation. In this video, we had a chance to set up a live production database and see just how easy that is with Heroku. In our next video, we are going to show how to set up environment variables in Heroku. In the previous video, we had a chance to set up a live production database and see just how easy that is with Heroku. This is the fourth video in this section, and in this video we will be covering just what environment variables are, why they are beneficial and quite frankly needful, and what variables we'll need to set to view our application. In the previous video, we got an introduction to environment variables with the Mongo Lab URI. This variable was added automatically when we created the database. It was leveraged in our server config file. We will once again be looking at this server config file for the remainder of our environment variables. There are two more environment variables that we might need to set. The first one is the port, if we want to execute on a different port. The second we are most certainly going to have to set. It defines the location at which files are served for our application. In our example, we are not going to set the port, so let's dig into the static site route. Going to our Settings tab on our Heroku application, we need to reveal the config vars. We need to add a new variable. We are adding static site route, and we're going to set it to /app/dist. The dist folder is what contains the client-side files, and the /app is the root folder the application is deployed into. Environment variables are important because they allow us to configure our environments without affecting our development environment. Pushing to production doesn't hurt anything because each of our dependencies has a configured environment variable, and will use its value if it exists. In development, these values don't exist. In production, they are all set up if necessary. With this variable in place, we can now actually view our application. In our next video, we are going to be viewing the live application. In the previous video, we set up our environment variables so that we can actually view our application. This is the fifth video in this section, and in this video we will be walking through our live application. To view our application, we have a number of options. We can navigate to the URL, we can go to our application in the Heroku dashboard, click on the little options icon and choose Open App, or we can also just type Heroku Open from the terminal. Taking a look at our application, we see that it's definitely an empty database. If we click on New Customer, we can add a customer to the database. Clicking Save Changes will take us to the All Customers listing and let us see the newly added customer. And we continue using the application to add a new sale to that customer, and even view the dashboard information. Taking a deeper look, let's pull up our Mongo Lab database again. Now we get to see our collections and that we have a single document in customers and sales. This is what it's all about, my friends. Congratulations, you've built and deployed a live Mean application. Now, just to wrap up, there are other deployment options out there. You can go with something like infrastructure as a service with Amazon AWS or Microsoft Azure. You can purchase your own static IP address and a server and deploy it locally if you want. Heroku was just a good option because of its simplicity. I also like Heroku because of its scalability. That ends this section, and in this section we covered what everybody wants to get to, deploying a live application. With Heroku, the process really is very simple. There are many other options out there. I just prefer Heroku over others for live Mean stack applications. In our next section, we are going to be discussing other options for tools. WebStorm isn't all that expensive at this point, but sometimes people just need or even want something more lightweight. Those tools will be discussed and their caveats. In the previous section, we had a chance to look at our live application deployed to Heroku. That was some real exciting stuff, I gotta admit. This is the last of an 8-section course. And over the next 3 videos, we will be discovering how we can use Sublime to build Mean applications instead of WebStorm, which plugins would come in handy, and look at any caveats that might exist while using Sublime. This is the first video in this section, and in this video we will be looking at some plugins that will change the way you develop in Sublime. We will be installing package control and code formatting solution, and some syntax highlighting solutions as well. The first thing you'll want to do is install Sublime, which can be found here. After getting Sublime installed, we want to get package control installed. It can be found here. To install, just copy the import command. For Sublime, open the console with Control backtick, or on a Mac, Command backtick, and paste in the import command and press enter. If this is a brand new installation of Sublime, you'll most likely get this message. Go ahead and restart Sublime. With package control installed, we can get some packages that will really aid in development. To install a package, we just press Command-Shift-P or Control-Shift-P if we're on Windows. We type install and press enter when you see package control :install package selected. Type in the name of the package to filter and press enter to install it. The first package we're going to install is HTML-CSS-JS Prettify. This is a great package for formatting code. Inside of a file, you just press Command-Shift-H or Control-Shift-H if you're on Windows to format the code. Settings are pretty straightforward as well. If we go to the Preferences menu and choose the Set Prettify Preferences options, we can actually set things like file extensions and number of spaces. The 2 preferences you'll work with the most, which span HTML, CSS, and JS, are allowed file extensions and indent size. Personally, I generally set the indent size to 2 instead of 4. Now we're going to install less. This is going to provide us with syntax highlighting for less files. After that, we're going to install AngularJS. This is going to provide us with a little bit of code completion surrounding Angular. We're also going to install a package named Terminal. This is going to allow us to open a terminal right from Sublime in either the project root or selected file root. On a Mac, it'd be Command-Shift-T, that would open the selected file root, and Command-Option-Shift-T would open the project root. Being able to open a terminal at the right folder so quickly is going to prove helpful. In this video, we discussed which plugins make developing in Sublime more effective. These are going to be lifesavers. In our next video, we are going to be talking about using the tools. In the previous video, we discussed which plugins make developing in Sublime more effective. Believe me, they'll be lifesavers. Now, this is the second video in the section, and in this video we will be covering how we will use Sublime, including the plugins we just installed. Now that we have some necessary plugins, let's break down how we might use Sublime to work on an application. The first thing we'll want to be able to do is open Sublime from a file, folder, or terminal. We'll first deal with the terminal. In a terminal, we're going to type the following. This is going to allow us to open Sublime in a terminal by typing this command. Now that we can open Sublime with a lot more ease, let's see how some of these other tools work. The first is the formatting tool. Now, this is just a little pro tip here. If the formatting is not working, check the file extension. It may not be in the list. You can get to that file extension list by going to the preferences for the formatter. Formatting the file is simple. Open the file and press Command-Shift-H or Control-Shift-H if you're on Windows. The next tool that's going to prove useful is the terminal plugin we installed. To get to the folder the currently selected file is in, press Command-Shift-T or Control-Shift-T on Windows. To get to the project root, which will be the most useful, press Command-Option-Shift-T or Control-Alt-Shift-T on Windows. This tool is necessary because running your application will require the terminal. For example, if we wanted to run our application, we could open the project root in the terminal and then simply execute Grunt or Grunt Mock. We could also execute Grunt M for Mocha or Grunt K for Karma. That brings us to the end of this video. We learned how to use some of the tools we installed, and in our next video, we are going to be looking at the caveats that exist with using Sublime over WebStorm. Welcome to the last video of this course. This is the third video in this section, and in this video we will be covering what caveats exist for leaving the comfort of the IDE of WebStorm to use something like Sublime. Now, this is going to be pretty straightforward. Some of the caveats that exist are, there is no integrated debugging, no real code completion for external libraries, like custom scripts that you write. Further, there are no run configurations. This means setting environment variables to simulate production is much more difficult. With WebStorm, you can debug your Node and Angular applications in the IDE. While I normally do not debug my Angular code in the IDE, I usually use the browser tools. I often debug my Node applications there. It's much better than console logs. This is something you're missing with Sublime. We did add a plugin for some code completion for Angular, and there are probably some other ones out there. However, WebStorm, when configured right, can also provide code completion for Node and Bower libraries along with your own code. This is not something that I have found configurable in Sublime. Having run configurations is probably not a deal breaker. But the run configurations are kind of nice at times because you can set the environment variables, and that's why there's a production run configuration that serves from the dist folder instead of the default build folder. Before we finish, let's review some resources that will be helpful for you in the future as you build new applications. Shamelessly, I'm going to plug my site at consultwithmike.us because you can find thousands of dollars in free content you won't find on other sites right there. Another very helpful resource will be the site I derived my backend-less development strategy from, and so I want to plug Jeremy right here. I really appreciated his post, and it really structured my solution. Another phenomenal resource for more complex situations is going to be Todd Motto, an obvious big player in the community. A book that a friend of mine referred to me is the NG book. I've given it away on my site before. It's a phenomenal book. Absolutely an in-depth book for Angular. Need to take a look at it. And there are literally hundreds of more resources out there, but these are some good starts. Well, we are now at the end of this section, and in this section we did cover how you might use Sublime for development, what plugins are useful, and any caveats that might have existed. Until we meet again, remember what John Wood said about programming. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live.